Okay, welcome everyone. I see that there are already people connecting, so I can start the session of today. Welcome to the third day of our conference, ESOGPT24. Today it's probably, I don't know, maybe I'm biased, but it's one of my favorite days. So today the effort that we are trying to do, what we want to explore is to with the help of professionals in cognitive psychology to cross-match, basically, to make an interdisciplinary effort and understand the GPT technology and LLM technologies that we are, as we learned in the past days, that we are starting to explore and use in astronomy, to understand implication of the use of such technologies in general of AI in research and what means for several aspects related to things that we have been discussing, which is trust, which is how to build trust, how to interface, what's the consequence for our capabilities to learn, to grow as humans, to learn, and as a researcher, of course, as well. So this is all a bit the idea of today. And of course, as an astronomer, I'm very happy to give the floor to present and to introduce the session and to chair the session to Sandra Grinskle, right? Sorry.
Grinskle, yeah.
Grinskle, yeah. Exactly, Grinskle. Thank you, Sandra. It's good. It's very, so for us, it's great. We met with the with the idea of trying to bring together these two communities, which is a challenging task. And Sandra kindly agreed to join us in this adventure, basically. So thank you, Sandra. Sandra, just to give a small introduction, but Sandra, you can also introduce yourself. It would be great actually if you can spend a couple of minutes. But Sandra is a researcher with expertise in human technology interaction with cognitive enhancement and self-estimation and cognitive abilities. So this is this brand that is critical for the theme or for the scope of this day. So Sandra, please, I give you the floor, but I stay here. So any technical issue, anything, I will be here to support, of course, the event. Thank you.
Thank you, Giacomo. I'm not sure if you can see me at the moment.
We can see you.
You
yes.
can, okay, because I don't see myself. Yeah. So I have a bit technical issues today. My laptop decided to do an update. That's why I'm joining you with my phone at the moment. But as soon as my laptop is done, I'm going to switch again. And this is also the reason why I don't see my notes right now. But luckily, I know the next speaker a bit, so I can also introduce him without my notes. So we're going to hear now a talk by an invited speaker. We're happy to have Patrick Weis here, who is a cognitive psychologist who finished his PhD in the US, but is now a postdoc at the University of Würzburg in Germany. And I cannot read your title, Patrick, which I was supposed to do because I don't have my notes, but I think if you just start sharing your slides, I think we will see your title. And yeah, just as a reminder for this invited talks, we have 30 minutes plus 5 minutes of discussion. And afterwards, we have a couple of contributed talks. And then at the end of the day, we will have our shared discussion round. So I think without further ado, we look forward to what Patrick will tell us about why and when problem solvers use their environments to help them think.
Well, thank you, Sandra, and thanks for the invitation. Welcome everybody to my talk. And as Sandra said, I'll be talking about thinking outside the box. So maybe two things I want to note up front. First of all, I'm talking about thinking outside the box, or how we use the environment for thought processes. So I'm not specifically targeting large language models. I am trying to touch a little bit upon them, but my focus is a little bit more general. Then the second thing I wanted to mention is I very rarely talk to astronomers, which is obviously my loss, but it provides somewhat of a challenge to to say the right things that are interesting to you. So I would be very happy to get some feedback, which parts were interesting, which parts were not so interesting. All right. So I said I'm talking about thinking outside the box. So what do I mean with that? Here's an example. So imagine you want to solve a math problem, a physics problem. Very frequently, you will need to take some notes. Or at least most problems are so complicated you can't quite solve them in your mind only. And this is what the historian Charles Weiner, learned when talking to Richard Feynman. So he brought some notes to Richard Feynman into an interview and told him, well, those notes are a record of your work. And Feynman wasn't too happy about that. He said, no, it's not really a record, the work. And this somehow should convey to you that, yeah, using the environment for thinking is nothing you only do out of fun. Sometimes you just need it. And thought is pretty much intertwined with the environment very frequently, especially when tasks are getting a little bit more complex. So for the remainder of the talk, I will now next talk a little bit about the model, how I conceptualize thinking with the environment. And then for the most part, I will talk about reasons for thinking with the environment. So why and when do we use the environment, and when and why do we only need our mind without reaching out into the environment? Then I will talk a little bit about the consequences. So what happens when you actually use the environment to help you think? And then lastly, I'm trying to talk a little bit about potential implications. For example, for using large language models to support thought. So here's my pretty easy model. And everything I'll be talking about during the next 20 minutes can be squeezed into that model. So I'm talking a lot about experiments. So we invited people into our labs, or we did online experiments, and all these participants we had usually were presented with a problem. Then they needed to figure out how to solve the problem. And frequently, they had external strategies and internal strategies available to solve the problem. Sometimes they even had several external strategies available. And then eventually, hopefully, they found the solution to the problem. So how does it look like? For example, a problem might be to figure out how far the galaxy is away. And sometimes, yeah, you just don't know, right? So you need to maybe ask Taylor. Taylor's around, ask Taylor. Taylor says, well, easy. That's galaxy M32 at 0.77 megaparsec. And you got your solution. But sometimes Taylor isn't around. So you might be inclined to, for example, ask ChatGPT or a more specialized large language model. The best way possible would be probably if you already knew how far the galaxy is away. So you don't even need an external strategy, but simply can engage in internal memory recall, which would here be an internal strategy. So just to remind you, for the remainder of the talk, this will be the scheme I'm using. You have a task, and then you can decide, do I want to use an external strategy? And sometimes people would decide between two different external strategies. So, as I said, for the most part of the talk, I will be talking about reasons for thinking with the environment. I'll start with that now. So imagine you want to build an extra large telescope. So obviously what you need is a pile of bricks. But then most likely you will also need some sort of instructional blueprint. So let's formalize this a bit. You have a task, build an extra large telescope. But the first thing you need to do is what I would call an external strategy. You will need to look at the blueprint to know what you have to do. And then you need to remember parts of the blueprint to remember when you actually start building the telescope. So here I would frame this as an internal strategy. You have to remember where to put the next couple of bricks, keep them in working memory, build them, and then access the blueprint again. So unfortunately, this hasn't been done in cognitive science research, but something very similar has been done. So in this cognitive science task now, people don't need to build a large telescope, but they need to recreate the pattern you see on the right side. They can do so by going to the brick or block pile, click and drag the blocks, and then drag to this work in progress window you see on the bottom until they're finished. Now, in an analogous manner to what happened with when building the large telescope, they can remember different blocks from the blueprint when working on the work in progress window. So there's one more catch to this paradigm here. You don't always see the blueprint. So while working on building the pattern, you can't see the blueprint. You have to hover over the blueprint to see it. And I hope I didn't lose you, because so now the important thing is, how often do people hover over the blueprint to see the blueprint? So formalize this looks like that. Your task is again to build a colored pattern. To do so, you have to hover over the blueprint. And in this experiment, participants remembered 1.4 blocks. So they hovered over the blueprint, saw the blueprint, and then they started building the pattern, but only 1.4 blocks on average. And then they needed to look at the blueprint again. And then they built 1.4 blocks, and then they hovered over the blueprint again. Now, interestingly, when the blueprint didn't appear right away after hovering over it, but there was a loading time of 200 milliseconds, then participants adjusted their behavior. Now they didn't remember 1.4 blocks. Now they remembered 1.7 blocks. So when the external strategy, the accessing the blueprint information, when that got less effective, less efficient, people adjusted and remembered more internally before accessing the blueprint again. Now, when the access time was 1.6 seconds, so loading needed 1.6 seconds, people remembered even more internally. What this tells us is that's a first hint that people are, somewhat adaptive to what's happening in their environment, and they can at least adjust to loading times. So now you might think, well, that's pretty far away from using large language models, and you're probably right. So hopefully we can move some steps closer. So in another experiment, we brought trivia questions to our participants. So pretty similar to the question I showed you in the beginning. How far away is a galaxy? But this time, participants wouldn't need to solve the trivia questions on their own, but they could ask one of those algorithms. We completely made up these algorithms, so they wouldn't be biased due to experience with them. The only difference between those both algorithms was now how fast they were at solving the trivia questions. So in this case, the pattern matching algorithm needed 1.4 seconds to solve the trivia question. The semantic bootstrap algorithm was 400 milliseconds faster. It only needed 1 second. Now the question is, when our participants had the choice between both algorithms, would they choose the faster one? And the answer is they did. So in 78% of cases, people used the semantic bootstrap algorithm to solve the trivia question, which is good news. So people, again, noticed which algorithm was faster and used that algorithm. Even when we made the task a little trickier, such that the difference between both algorithms was only 80 milliseconds, people still preferred the faster algorithm. Only in 58% of the time, but still, they seem to be somehow sensitive to even small speed differences between algorithms. So far I talked about speed. Now I want to talk about a different performance metric. Now I'm talking about accuracy. To do that, I'll introduce a new task. In this task, participants looked at 2 objects. You can see the one on the left and the one on the right. The question was to say whether the left object matches the right one. So in this case, both objects are literally identical. So participants would need to indicate, yeah, that's a match. In this example, the right object is rotated a little bit. But when you rotate it on the screen, it can still match the left object. So this is still a match. However, when the right object looks like that, it can't be rotated on the screen in a way that it matches the left one. So in this case, it would be a mismatch because it would need to be mirrored to match the left object. So to solve these kind of tasks, it would be enough for participants to only rely on their mind. And when people only use their mind or their brain to solve these tasks, they needed 2.2 seconds, which is fine, and were 91% correct, which is also fine. Now, crucially, we had a different condition. In this condition, we provided our participants with some help. So we asked one group of participants to only rely on a computer-based strategy to solve the task. This looked like that. So participants would look at the screen, and then they could use the keyboard to simply rotate the screen on the right side. So instead of engaging in mental rotation, they could now do computer-based rotation. So they substituted a mental process with a technology-based process. Something that you can also do with, obviously, large language models. So, and in this case, when we asked participants to only rely on this computer-based process, they were a little slower, but they were quite substantially more correct. Now, the crucial question here is, when we ask participants to be as correct as possible, how do they decide when they have both options available? And turns out, they by far prefer the computer-based strategy in 96% of the time, which is adaptive because it's the more accurate strategy. Interestingly so, when we ask them to be as fast as possible, this preference is way less pronounced, and they will use the computer-based strategy way less. Which brings me to the conclusion that participants cannot only monitor speed, but also accuracy, and at least to some degree, also make adaptive decisions between which strategy to use. Now, there's another performance metric I want to talk about. You already know the task, so we added a different manipulation to the task. So in this case, participants could again choose between an internal strategy, mental rotation, and an external strategy, computer-based or manual rotation. But this time, the manual rotation would only work 90% of the time. 10% of the time, they would press the key, but the object wouldn't turn, and an error would be shown. Question is, how frequently do participants use unreliable external strategies? And it turns out they use it less than before, in this case, 74% of the time, but they still use it quite a lot. When we decrease the reliability to 60%, they use it even less, but at least from my point of view, they still use it quite a lot. Which brings me to my interim conclusion that we are actually, as humans, pretty good at monitoring speed, accuracy, reliability. Not perfect, but we're pretty good. We can monitor it and adjust our strategies accordingly, which is actually pretty good news for using novel technologies. But performance isn't the only reason for why we use an external strategy. Reason is what we simply believe the performance to be. So let me walk you through another experiment. So here we lied to our participants. This time our external strategy was again 90% reliable, but we told them, well, the rotation actually only works 60% of the cases. So we lied to them and told them it's only 60% reliable, even though it was 90% reliable. And when you look at what participants did, you can see that participants believed us and they used the external strategy less. So it's not only actual performance of external strategy that matters. It's also what you believe the actual reliability is. So thinking about large language models, it's not only the performance you're thinking about, it's also what you believe the large language model can do. So when we did this in another condition where we again lied to participants, the same pattern emerged. So when the external strategy was 60% reliable, and we told them it was only 30% reliable, we again lied to them. Again, they used it less. And that beliefs inform external strategy choice doesn't only work for reliability, it also works for speed beliefs. So let's get back to that trivia paradigm. So as you remember, we posed trivia questions to participants, and they had the choice between two algorithms. Now, crucially, in this condition, both algorithms had the exact same speed. The only difference was that there was an observation phase. So before they had the choice between those algorithms, they would need to observe both algorithms. And one algorithm was pretty fast at the beginning of the observation phase, and one was fast in the middle of the observation phase, but slow in the beginning. Now, it might be that people form their beliefs about speed initially when encountering a novel external strategy. If that was the case, people would be more inclined to use the semantic bootstrap algorithm to solve the trivia question in comparison to the pattern matching algorithm. Even so, again, on average, they were equally fast. The only difference is that semantic bootstrap was quick at the very beginning of observing it. And this was indeed the case. So our participants preferred the semantic bootstrap algorithm. So they used it in 56% of the time, which is a 12 percentage point difference to the other algorithm. And then when we asked participants, well, which algorithm was faster? They also more frequently told us that, well, the semantic bootstrap algorithm was faster. Even though, again, it was not faster. It only was fast in the beginning, but then afterwards it was slower. So taking this whole belief thing a step further, I now want to talk about mental models, which are pretty much a conglomerate of beliefs. So here we asked participants to solve a social task. So participants would see a face, and we asked them, well, which emotion do you see in that face? And here, participants could either click on the picture of a human being to help them solve the question, or of a robot to help them solve the question. And participants here could also solve the question on their own. So when we did this with participants, first of all, we found that in 2/3 of the cases, participants wanted to solve the task on their own. So they kind of liked solving the social task on their own. But you can also see that they preferred advice from the human being over advice from the robot, which suggests that we have the mental model of the human being as being rather social and capable of solving social tasks, but robots, even if they have human features, probably are not as good as humans are in the social task. Even so, performance between the human and the robot agent was identical in this task. So how does it look with arithmetic tasks? Here, the task was to subtract the black dots from the gray dots you see in the top right corner. So when the task was of arithmetic nature, participants now preferred by far the robot. Again, most likely, people have mental models about robots and humans. And robots are seen as more capable in those more arithmetic math-like tasks. Now, the next thing we did is we provided participants with two smartphone apps that we created. One was called OmniLearn, the other was called Pattern Analytics. And when we didn't provide any additional information, participants chose them in equal frequency. So both of them were chosen 30% of the time to solve the arithmetic task. But now, more interestingly, when we altered the mental model of the app, so when we told them, well, OmniLearn was originally built to recognize familiar faces, and pattern analytics was originally built to help children learn math, then participants by far preferred pattern analytics for solving the arithmetic task. It might seem somehow obvious, but what you can see here is that explicit metacognition, or providing such explicit information, might be a human superpower, how Jutta and Chris Frith proposed. So the idea is that just providing information, talking to people, helps a lot by understanding our environment. But also here, there's a catch. So as you've seen in the reliability experiment, the communicated information can be false. And also, when you create such explicit beliefs about something, those might also not be always correct. They can emerge from biases. For example, you might pay more attention to initial episodes with an external strategy. And that way, you're maybe not so sensitive to changes in performance of the strategy. Which now brings me to the last topic regarding reasons for using external strategies, which is multitasking. So remember, people here have to build a colored pattern from a blueprint. In this iteration of the paradigm, the baseline performance was that participants remembered 2 blocks before coming back to the blueprint. But now, crucially, there was a condition where participants had a secondary task. So while building the colored pattern, they also had to check for an auditory signal. So there was an auditory signal stream playing in the background, and they had to attend to targets that were changing all the time. And when this happened, they now only remembered 1.2 blocks before coming back to the blueprint, which tells us they use this external strategy of looking up the information way more frequently. So my conclusion here is that external strategies can help seizing other cognitive opportunities. So when you have better stuff to do, maybe or frequently you can use more external strategies, because at the end, using your mind is often very costly. So I've been talking about 3 reasons now for why people use external strategies, but I just need to add this note. So this list is not complete and exhaustive. There's other reasons. We might hear about trust later on. But from my point of view, I think those are the 3 most important ones. But this is obviously arguable. The next topic I want to talk about is consequences of thinking with the environment. This will be pretty brief. So here I brought another paradigm for you. So imagine you have to learn a word list. Let's say the word list is cookie, willingness, karaoke, and princess. And then one group of participants can save this list on a computer, so as a PDF or whatever. And then another group of participants is not allowed to save the list. And then you have to learn another list of words. So let's say forest, emotion, cabinet, shield. And then your task is to recall word list B. Then you find that when you were able, then the group of participants who was able to save list A was better at recalling list B than the group who was not able to save list A. So the idea here is that when you save the list, you somehow get rid of those words in your mind, such that they can interfere less with learning new stuff, which in the end leads to better memory. So one consequence of using external strategies is to create better internal memory, better learning for future stuff you have to learn. But there's also the reverse. So here, in this paradigm, participants had to solve alphanumeric equations. So what's that? Participants would read something like A plus 3 equals D and need to indicate whether this equation is correct or not. To do so, they can count up the initial letter by as many times as indicated by the number. So A plus 3 equals D would be A plus 1 is B, plus 1 is C, plus 1 is D. So A plus 3 equals D is correct, because if you count the alphabet by 3 letters, you end up at D. A plus C equals E would be incorrect. So it's like math tasks, but a little bit more complicated. Again, there were 2 groups. One group was able to use a calculator, a special calculator for calculating alphanumeric stuff, and another group was not able to use the calculator. Now, interestingly, those both groups had to solve the equations without the calculator in the end. And when that happened, when both groups were not allowed to use the calculator, the one without help initially was way quicker. So that's a 600 milliseconds difference here. That's pretty large in the cognitive science domain. So what happened? What happened is that the group who was not able to use the calculator in the first place established very efficient memory traces. So think about what's 7 times 3. When you solve the equation 7 times 3, you don't compute 7 times 3. You simply recall the solution. You know it's 21. You just recall it from memory. And this quick recall from memory is not necessarily built up when you're using a calculator or an external strategy. So what happened here is that people who used the calculator needed to compute the solutions in the end, while people that did not use the calculator in the first place had access to these very quick memory traces that they could use to solve the equations. Which was, by the way, also shown in another condition where people were asked to please try retrieve the solution from memory before using the calculator. And in this group, again, they were pretty fast in the end. So this is all I wanted to tell you about consequences. And I know, yeah, I already talked a lot. So the last point I want to tell you about is implications for using large language models from talked about so far. So I'm first presenting you with the results from, I guess it was Copilot. So the first thing I want you to know is, well, what are the guidelines for using large language models in problem solving when I ask a large language model? And I was interested whether the guidelines that the large language model came up with are the same as I came up with. And the short answer is no, they're completely different. I'm still showing you these. Please don't read through them. You might be able to read through them later on. I will now only talk about my guidelines. So which is a brief summary of my talk. So my first point would be that pretty straightforward. You should compare different strategies if that's possible, because I hope I convinced you that we are not bad at monitoring performance. So try out different strategies and try to compare them. Second point is you should probably leverage explicit metacognition, the human superpower. So simply talk to people about specific strategies, read up on the performance of specific strategies, but always keep in mind that people might lie to you. There is corporate interests and so on. So you can get fooled by wrong information. And if you stick to wrong information about strategy, you probably will use it in the wrong way, in a way that's not maximizing performance. Then it's probably also a good idea to outsource thinking to large language models when you have more important, more pressing things to do. Because after all, doing stuff with your mind is pretty precious. And then lastly, and that's probably the most tricky one, is that it might help to keep learning curves in mind. Because, for example, I told you that memory access, internal memory access, is a very efficient strategy, but it has a steep learning curve. You have to establish that memory over time. And when you always rely on strategy, on technology, and not try to build up that memory, then you are not performing well in the long run. So with that, I want to close my talk. I want to thank you for listening. And I also want to thank Eva and Wilfried, with whom I did most of the research I was talking about today.
Thank you, Patrick. Very, very interesting, very nice talk. I think we have time for 1 or 2 questions before we move on to the next talk. And I think there's one in the comments, which I will read to you. Fabio is commenting, I have zillions of comments and questions. That's good. We can also pick them up later in the discussion section. And to just pick up one now, do you consider things like mind maps or conceptual maps as external or internal strategies?
I mean, I touched upon that a little bit with this pattern task. Sometimes internal and external is nothing really distinct, but an interactive process. So there's no easy answer. I would say you can conceptualize an external strategy as just picking something up with your eyes, remember it, and then use it. In that way, I would say using mind maps, probably, just like Feynman's use of nodes, is both internal and external strategies, but they are like micro strategies. You use one micro strategy here, one micro strategy here, and you have like, yeah, a very dynamic use of both strategies that happen in a narrow time frame. That's the best way I can answer the question.
Thank you. I think Giacomo.
Yes, I do also have 2 million questions. It was really, first of all, thank you very much, Patrick. It was really, really beautiful and really, really interesting, fascinating. So please apologize. This is an astronomer question. So but you may. So I was really intrigued by the explicit metacognition. I took notes. That's why I'm reading the metacognition. Explicit metacognition, which a concept I'm not familiar with. So, but I was wondering, in light of what you told us. So I understand this fact. So basically, talking to peers or to colleagues, basically to get to exercise explicit metacognition. But I was wondering, is fundamental for human growth. That's what you told us. But I was wondering, so the use of LLM models or GPT models, to some extent, will affect in your research. So it will affect the way we use explicit metacognition. So the fact that we talk less or we ask less to our colleagues will kind of affect our this human behavior and to which with which consequences.
I think the point I wanted to make is that you can frame using technology as a community effort. You have to somehow figure out how to use a strategy best. And frequently you can't do that on your own. And one way of doing it is to talk to other people and bring opinions together. So one group has had good performance with using the LLM, but another group had no good performance. And I mean, you could call it swarm intelligence, or there's different terms for it. But I think it's important to distinguish between how you perceive, how you perform with a large language model, and how you can get that piece of information from other individuals or other people, because the one is an implicit signal. You monitor your performance. You don't necessarily need to be able to talk about it. You don't need to be able to say how fast something was, even so you behave that way. But when you want to share that information with other people, it has to be explicit. You have to be able to talk about it. And this is, I think, one of the great things that humankind has. We have language, we can talk to other people, we can say, well, performance for me was great, but performance for my colleague wasn't that great. And like by bringing all these information together, we can inform how we can use external strategies. And this is also what happened over time. Was like, I mean, we had calculators, we had all sorts of things, and we needed to figure out as a society how much we want to use them. And this usually works by sharing, for example, performance information via language channels. And this might be pretty obvious, but I think it's fundamental that we realize how important this explicit communication of, for example, performance information is. Did somehow answer your question?
Yeah, indeed. But so I have another follow-up question, but maybe it's too, I don't know, Sandra, can we go on or?
I think if you're quick,
Yeah, I was wondering.
we might shorten the break a bit then.
No, I don't know, because you said, for example, the example of the calculator, right? So it is all, so to me it seems that on one side, so it has an effect on the internal strategy, the use of an external strategy like a calculator, right? Because and that effect so is basically I'm using less my memory cell, basically, if I understand correctly. And what does it mean on a long term? What's going to happen?
So with the calculator case, the problem is that, and so maybe first things first, you have lots of different cognitive functions. Memory is one of them. And the way building up memory traces works is that you benefit the most from trying to retrieve something from memory. Whenever you try to retrieve something from memory, you're strengthening that trace and it will get better. Now, when you use a calculator, you usually don't try to retrieve anything from memory. You just put in the numbers and see the result. And that's not enough to create that strong memory trace. But what you can do is you can challenge yourself a little bit while using the calculator. So when you try to first retrieve the solution before using the calculator, then you build up the memory trace because you try to challenge a little bit your memory. But if you don't do that, if you omit that, if you just use the calculator without trying to form the memory trace, then you don't. And I mean, I assume similar things apply when you're looking for knowledge in the internet or using large language models. If you are very active about it and you incorporate it in other cognitive processes in your brain, you might be well off. But if you don't, if you do it in a very passive way, then you might have a problem. Yeah.
Okay.
Thank you, Patrick. Yeah, I think this is very interesting, and we should talk more about this later. Yesterday, there were some discussions in the chat about children's and technology use, and I think if we think about children always using calculators or stuff like that from an early age on, this might also get a bit problematic. We have to move on to our next talk. Zechang. I'm very sorry if I pronounced his names completely wrong. Please bear with me. I'm not sure if you already have your rights, San.
I'm now making co-host. Yes, now it's co-host.
Okay, now you should be co-host and you should be able to turn on your camera, your microphone, and to share your slides.
Hi.
Hi.
Okay. Let me my screen. All right.
Perfect. So just as a reminder for this next 3 talks that we have 15 minutes planned with a 5-minute short discussion. Yeah, and now we will hear about interpreting multiband galaxy observations with large language model-based agents.
Yeah, okay. So maybe I can get started. Okay, so thank you. And I'm Zechang from Tsinghua University in Beijing, China, and I'm really honored to have this chance to introduce our recent work about a prototype of AI astronomer. And this work was in collaboration with Ohio State University and Microsoft Research Asia. And so when Microsoft hired me to build some AI scientist, what came into my mind is this sentence. So astronomers are storytellers. This is when this sentence impressed me a lot when I learn something basic about observational astronomy. But what is a storyteller really mean? And here is something from the Turing Award winner, Julia Pearl. So what a storyteller means is that we use some causal model to interpret observation, but causal model cannot be learned alone from data or association because I don't want to dive too much about the philosophy behind, but the thing is that why there is no AlphaFold in astronomy, because we actually don't care if we can predict everything. But what we really care is that we want to know the behind mechanism to interpret the phenomena. And so in the foreseeable future, we will never build an AI astronomer, because proposing totally new causal model to explain the observation is almost impossible for currently AI system, even for ChatGPT. And but the most advanced AI assistants can help researchers to validate and rule out different causal models, for example, existing physical theories, compare them to the observations. So this is what I will focus on in this talk. So the downstream task we are focusing on is that can we use AI to interpret a observation of a single galaxy with existing galaxy formation and evolution theory? This should be possible because this task doesn't involve with creativity and imagination. You can just validate and iterate all possible solutions to figure out which match the observation the most. And we actually have seen a lot of such papers in recently, especially the launch of James Webb Space Telescope. And can AI write a paper like that? The answer is no. This is still too hard, because this needs AI to understand spectra, to collect data from different sources and perform very complex and long logical reasoning, which is difficult for currently AI system. And can we define a more straightforward task? And here we find one. This is about the so-called SED fitting. Here I want to quote the definition of SED from Yuansen's PhD advisor, Charlie Corey. And basically what we do is that we have different components of the galaxy spectrum, and including the star formation history, metal content, and nebular emission, and also aging component. And our goal is to combine this different theoretical model into it together and then match them with the observations. And below the two figure is from the recently James Webb Little Red Dot papers, and there are two physical model for the two physical scenarios for the same data, which is one is dust-free AGN and another is dusty AGN. So although the task of SED fitting is to infer physical parameter, for example, the stellar mass and dusty attenuation from the photometric data alone, but it's actually not a fitting. It's a reasoning process. We're here to compare different SED model and filter out those are not reasonable and find those are most possible. And they are all correct, but also there is no wrong, because there is no ground truth or best fit for a single SED, because all those are possible within current theoretical framework. So that's what science do. And so what can AI do for the SED fitting? So we introduce something like a multi-agent framework designed to mimic the human reasoning process for a single galaxy. It can interact with the data and the SED modeling tool. We here use Yale. I think some of you may hear about them or actually have used it before. and it performs something like the tree search guided by its internal knowledge and memory to explore from simple to complex to refine the SDD model like humans do. And also it can learn from itself, past experience, and continuously refine its knowledge in a self-play reinforcement learning style. So here is an overview. You can see many different parts, which are about the input and also the reasoning process, which is about one-step reasoning. And it can also help knowledge and memory. And we finally derive our report by a summarization. I will introduce each part later. So about the input, we do not directly input the data into the agent, but we have transformed them into some text. For example, for the photometric data, we organize them into a JSON list. And for the SED model, it's the same way. And we also have some metric to indicate how well between the data and the SED model. This is because the variability for large vision model is very limited. They cannot understand the scientific plot very correctly. And about the reasoning process is actually a tree search process guided by knowledge and memory. And the agent will start from a very simple SED model, and he examines the discrepancies between the observation and the data. Then it iteratively explore different possible SED scenarios, and it tries these different solutions and iteratively refine them. This is the reasoning process. And here is a procedural code for this process. Basically, it's some tree search, and at each time you generate some new SED model and evaluate them. Then you add those possible states into the tree, and also you update your memory. And here is some automatic learning process I will introduce later. Your conclusion is derived from the reasoning process, as those discussion section in the astronomical paper. Yeah. So, but one question is that how does MapHisto know how to perform SED fitting? So here we incorporate an external knowledge base in natural language to improve its proficiency in SED fitting. The knowledge is in natural language, then it can be written by human expert and are very flexible. You can edit and remove or rewrite it by yourself. And they can also be transferred between different large language models, different SED fitting codes, and even become a tutorial for human researchers. At least for me, I learned how to do SED fitting through the knowledge it provided. Yeah, and more importantly, they can be obtained through their internal trial and field experience. I will introduce this next. And so here is some examples of the distilled knowledge. You can find them. They are just some instruction to tell you to which parameter, which SED module affect which part of the emission, the light emitted by the galaxy. So how MapHisto learn in a reinforcement learning style? So in reinforcement learning task, you need to define some reward. For example, if you play Go, you need to define who is the winner. But in the SED fitting or in scientific discovery task, there is no reward. If you have know the reward, which means that you have know the results very clear, this is unrealistic. So, but we have some temporary reward for each action. For example, the left panel is worse than the right panel because you can find significantly underestimation in the near-infrared bands. So if you can understand which state is better, then you can tell the large language model to learn from those actions which really meaningful. And here is the learning process. So MapHisto distills common insights from its fitting history, and we avoid the bias in large language model by adding some random explorations. And we also validate the knowledge because harmful and erroneous knowledge will make the performance worse. And we perform random control trial to estimate the effect for each knowledge, and we only keep those works. And finally, we use large language model and optimizer. They basically integrate the newly distilled knowledge into the external knowledge base to avoid redundancy and internal conflicts. So does our learning mechanism effective? The result is yes, and the run depth is defined how many observations have been fitted, so how many steps we have learned. And you can find if the running step is about 10, the chi-square decreased very fast against the inference depth. The inference depth is the search depth in the search tree. So we find the learning mechanism is effective, and also our agent can propose better and better hypothesis about the SED model during its search process. And here is a scientific application in which we use MathHisto to explore the most hot topics recently. We use it to fit the SED of the little red dots discovered by James Webb. So the little red dot galaxy are very interesting because they challenge the lambda CDM to be the massive galaxies in high redshift, or the galaxy formation history, because else the mass transition efficient will be too high, or the agent theory, because otherwise the agent fraction will be too high in high redshift. So here is one source recorded in Pablo 2024, and there are two possible scenarios for this red dot. This is about a dust-free agent galaxy and also a dusty star-forming galaxy. And we can find MathHisto can correctly find the two possible physical explanations. And here the red panel is actually SED fitting result for the two solution. You can find that it fits the data very well, and the parameters are reasonable. Also, it can find some really astonishing results because we do not incorporate any prior into the search process. So here, this result is also from the paper from Pablo, the data from the Pablo, but you can find in this case, the agent find the AV magnitude to be about 10, and the stellar mass will be about 30. This is astonishing because if you find such massive galaxy in redshift about 8, this is impossible. But we know that this is largely due to the limited constraint power of SED. But we here to show that our agent can give much more new understanding for current data. And so we also compare our results on different large language models. For example, with the Llama 3.1405B, which is the state-of-the-art open source large language models. We find for the median chi-square at each inference depth, the performance was very, very large within different large language models, and the performance of GPT-4o is the best. But if you check the best states, then all three models are possible. As such, you can consider your money and your science goal to balance the two objectives. Okay, so here I want to end my talk. So basically, the problem of AI for science is that science is an out-of-domain problem, but machine learning is an in-domain problem. And however, the ability for scientific thinking is in-domain data. So we can use large language model to learn how to think as an astronomer. And then we can link the two parts together to make real scientific discovery, which is the out of domain and the unknown. And basically, what we have done is that we build a robot to tell us possible physical scenarios for single galaxy multiband observation. And our framework is fully transparent reasoning process and can be easily integrated into currently research framework. You basically have just a lot of graduate students to do the SED fitting day and night. So finally, I call this agent map history as it's just like a mirror to make me rethink the role of human in research and release me from the endless chores, at least in a small task, just like what Mephisto has did in the ancient German tale, the Faucet. Yeah, thank you.
Thank you. Do we have one or two quick questions? There is one in the chat that I will read out from Mike. Did you also compare to O1? And if so, did you find a significant step improvement in metric performance from O1 compared to GPT-4 level models?
Hi, Mike. That's a really good question. So actually, we didn't compare it with O1 because O1 doesn't release the API access, even within Microsoft. So we have no access to the O1 API. Once we can access its API, we can definitely retest it. Yeah.
Thank you. Maybe while Aishwarya Girdhar could already prepare her slides, and while doing so, I have a question, Sam. So I'm not an astronomer. I'm not sure if I got what the SED is, but I also maybe don't need to get it. But my question is, can this tool that you presented us help students, astronomer students, to learn about the SED concept, or is it something for more advanced researchers who already have a basic knowledge?
Actually, it can do the both part. You can see that those knowledge were dig out by the agent by itself. So if a new coming graduate student, he have actually no knowledge about how to fit a SED, then he can read those knowledge digged out by the agent, and these are helpful to help him understand what's behind. Also, this agent tool is very friendly. The exercise is very simple. You just need to provide the data, and he will do everything by himself. So even non-astronomer, if he want to do some scientific discovery, he can just look at the image from James Webb and run this agent, and he will get an answer for what this galaxy is. And maybe he do some real scientific discovery. Yeah.
Great, thank you. Good, then we move on to the next talk by Aishwarya Girdhar, who still needs to share your slides. I think now it should be possible.
Yep, thanks, Andrew. Okay. Could you please help confirm that you see and hear everything okay?
We see the slides still in within PowerPoint, not in presentation mode yet.
Mm-hmm.
Now we see and hear everything very well.
Okay, thanks. Okay. Good. So, hi, I'm Aishwarya Girdhar, and I work as an astrophysics education researcher at the Chair of Physics Education Research at LMU. So just for a brief background, my training is as an astrophysicist, in which I made my PhD at ESO, actually, and also Newcastle University. So in that sense, it's quite a pleasure to come back to give a talk at ESO. So I would take a moment to thank the organizers for making it possible. And before I start talking to you about how we are recreating the early universe in classrooms, I also want to give a huge thank you to Jochen, Christoph, Atakan, and Anya, who make this project so much fun. Okay, so the TLDR of my talk today is basically going to be about how we are using an LLM as ChatGPT in the form of ChatGPT and technologies like augmented reality to create something that helps make astro education a bit better for the students. So our goal is to really pick up complicated topics and make the learning gains for students higher. And towards this end, I want to start with discussing some challenges that are commonly encountered in astro education research. Then I want to introduce the two tools I just mentioned and how we are using them and expecting them to solve the problem. And finally, I want to talk about this learning module in which we are focusing on investigating dark matter. So some of the common some of the common challenges that we face in astro education are here. So there's a lot of misconceptions that exist among students, which is quite tricky to fight. There's also often seen that astro education is done through a passive approach, and which also causes a low retention because the students themselves are not so much involved in this education. So we would like to change this, make them more a part of this, and we hope that this also supports their conceptual understanding. Then, of course, as many of you would appreciate, astrophysics does have a lot of abstract concepts, which of course are hard to visualize. And this makes understanding even more challenging for the students. And then finally, students do expect some feedback, and it is known to enhance learning, but it is important that we are able to accommodate for this without overloading the already overloaded teachers. So we try to address these limitations through the learning application that I will shortly talk about. But also something that is very important here to address is forming a bridge between the current research or the current complex research with classroom education, because this in itself can help the students in their future career prospects. Okay, so with that challenges in mind, I raised the question of how could ChatGPT help us? So this is indeed a fairly new field, and employing this in education is also new. But there are already some studies that actually tell that it is possible to use large language models like GPT as feedback providers in the learning process. There are also studies supporting the fact that how good GPT is to simulate conversations, and which in turn is able to encourage very good participation and support some critical thinking skills in students. And it is also seen to encourage a deeper reflection and help students inquire themselves to understand concepts a bit more deeply, hopefully. With this, I want to introduce the second tool. So augmented reality is, just as the name suggests, is augmenting your reality by adding some extra visualizations into this. So for example, in this image on the right, there's this reality, but there's this augmented visualization of the solar system placed on the table. And this is possible by seeing it through high-end devices like Microsoft HoloLens, which are smart glasses. But also it's possible by using smart devices like mobiles and tablets, and we try to use all of this at the chair here. Okay, why does this help? So as you can already imagine, due to this visualization, it is possible to give a form to the abstract concepts, which is empirically observed to increase motivation and learning in students, also promoting their collaboration and interaction. Okay. With all this background, I already want to jump into the learning module. So the module is mainly addressing the question of how are scientists looking for dark matter? And towards this question, there are two branches of the research. So there is a branch, let's say, located on Earth, and there's a branch located in space. Of course, there's a lot of collaboration between these two branches, but the high-end research facilities that are involved in this are, for today's context, ALICE particle detector on Earth, which is based at CERN. and the second in space is the International Space Station. How this forms into a picture of detecting dark matter is very nicely covered in this paper that I encourage you to read. But just briefly tying it all together is the particle detector can create collisions, proton-proton collisions at very high energies, which creates various particles. But one of these particles is also anti-helium nuclei. And why these are important is because if you look on the right now, if dark matter was considered to be weakly interacting particles, then in their collisions, one of the particles that would also be created are also anti-helium nuclei. So if we could somehow have some idea of the properties of this nuclei, or what is the probability that it would survive on its travel from the center of the galaxies to until the time that it reaches close to the Earth and is detected at ISS, putting these two facts together would really tell us something about dark matter and would actually point to existence of dark matter. And this scientific understanding is something that we try to bring into the classroom. So how do we do this? This is a very broad layout of the learning module. But what we want to start with is some theoretical background that addresses the new concepts that the students would encounter, and an introduction, which we do expect to be delivered by in a traditional teaching scenario through an educator. So our idea is not to replace this interaction of the students with the teacher. What we want to do is augment this learning by adding this learning application, which comes in the second phase, that gives the students a chance to interact and immerse themselves to learn about these research facilities like ALICE and ISS. And additionally, they get AI tutor in the form of ChatGPT to address to their questions. Of course, at the end, from the point of view of learning gain, we do want to measure that it helped the students. And for this, we have some concept-based worksheets that I will show shortly before the end. And we also want to analyze how cognitively challenging the application was for the students and how usable they found this application. So with this very brief outlay, let me focus a little bit more into this learning application that we are using. So once the students have some brief introduction and background into what they're doing today, we would like to divide them into particle physicists and astrophysicists. So they are scientists themselves for this day, and they have their own own research facilities to explore, and their own overarching questions that they need to answer. So the particle physicist group is studying about ALICE and its subdetectors. The astrophysicist group are studying about the ISS, in particular with the AMS experiment, which is actually catered to address this scientific question. And then in turn, at the end, after they've measured what they are observing, they come together and they collaborate just as scientists do, and they report what they found, and they try to hence estimate how much dark matter there could be. So since we intend to pilot the particle physics, the module related to ALICE in the next month, we have most of the things ready for this. And I would like to use this as an example to demonstrate how the tools that I'm talking about are used in this learning. And we want to use the results that we get from these pilot studies to then develop a module with the ISS, looking something very similar. Okay, so I've already said most of this, but ALICE is basically a particle collider based at CERN, at the Large Hadron Collider. It's colliding lead ions and protons to create something called the quark-gluon plasma. Basically, a QGP is a state of matter which can be seen to be at extreme temperature and densities, like those that were present very early in the universe. So if you look at this chart on the right, then about less than 1 second after the Big Bang, even before protons and neutrons are formed. So a phase that is present during that time. How does the learning module progress? Is firstly, the students have a Lego model in front of them, which is shown here on the left. And this is to create some haptic interaction. And they view this Lego model with the smart glasses, which which serves as a detection target. So as you can see on the red, when the LEGO model is detected, it can create this virtual model, which is seen here on the top, which is that of the Alice particle detector. And after this first stage of detection, they have certain tasks that takes them through a learning sequence. And between every task, they have an opportunity to talk to the GPT tutor that is present to help clarify doubts and address whatever concerns they may have before they move on to the next task. I will show you all the tasks at the end, but I want to first talk about how was this AI tutor created. So we wanted to base this on having an inquiry-based learning. So the idea is that students can themselves be involved in this learning, ask questions, really check the concepts they are forming. And with this, we wanted to provide some existing buttons that are present in this augmented reality application. So the students can already click on these buttons, and these buttons are already coded to have some pre-designed prompts. And these are then directly sent to GPT. But then we also acknowledge from learning sciences that students do appreciate having verbal feedback. And hence, we also wanted to give a user input through speech. And then we did incorporate for this, but then this involves another step that you need to translate the speech to text. And for this, we use Whisper, OpenAI's Whisper. And then, of course, once the GPT has the question, then it can send back the text, which is converted to speech and is available to the learner in audio as well as textual form. So this is how it's implemented, but looking at it a little bit cognitively. So it's not so straightforward to come up with an AI tutor that is also cognitively optimized, as you would also appreciate. So following the cognitive load theory, the cognitive loads can be categorized into three kinds: intrinsic, germane, and extraneous, and each one of them needs to be managed in a certain different way. So let's look a little bit into each of these and how they are, how we attempt to manage them. So the intrinsic load refers to the intrinsic complexity of the information that is being taught to the learners. So what we have done in this sense is to have ChatGPT after every task, and we do hope that this gives students a lot of opportunity to reduce this complexity, clarify whatever areas of struggles they are encountering. But also further, we have improvised this by having the student's age accounted for in the application. So we could give an approximate age group such that the GPT sends the answers or feedback back that is catered to the specific age group. And additionally, we also provide some buttons that actually help students to say, please explain me again, or please explain it a bit simply, or please repeat this, for example. Then the second kind of load is the germane load that we need to maximize. Basically means how do we link the new information with the current information? And towards this end, the first thing we try to do is we've designed the interaction with the GPT in a way that it holds the conversation with the user. So the subsequent messages are sort of getting stored with the GPT, which sort of helps build a rapport between the application and the learner that's using it. And then secondly, what we've also done is added some pre-prompts. So a context is always added to every button they press or every voice input they send. And this context always goes there along with this. So just to give you a brief look into how the context looks. So we tell GPT that the student is learning how the Alice detector helps in discovery of dark matter. And we tell the student has observed the proton-proton collision, for example, or wherever in this application the student is currently. We suggest to explain very briefly. And we say, please focus on what effects this component has on our main research goal, for example. And then we mention the subdetector that the student is actually learning about. Okay. Then comes the final kind of load that we've tried to address, which is the extraneous cognitive load, which is basically unnecessary and distracting information, and we need to minimize it. So for this, what we've done is we've also added additional context. While adding this context, we've also told GPT to really stay into the context of the learning application and not entertain some random questions. So for example, if a student was to ask, how is the weather today? And GPT would reply, and I apologize that it's in German, but basically GPT would reply, the weather today is not really relevant for the context of the Alice detector or the research we are doing today about dark matter. And please, we request you to focus on the aim for the day. So we hope that actually this really keeps them very focused on the research aims. Okay, so to give a very brief insight into how the learning progression goes. As I said, we have some introduction, and of course, there's some supporting learning material that we would like to use to show to students. This would then be followed by some very specific tasks that guides the learning progression. Firstly, to visualize Alice and be able to understand the important sub-detectors that are present there and be able to identify them in the Lego model as well as the virtual model. But then also to be able to understand the role that each of the sub-detector is playing in detecting anti-helium nuclei or in studying its properties. As a next step, we would like them to observe the collisions that happen in the particle detector, understand why the particle trajectories are curved, and be able to make this connection to the presence of magnetic field. And then finally, we want them to be able to estimate cross-section, which is calculate the survival probability of anti-helium, which would tell us what is the probability that it arrives close to the Earth. So this is just this is everything tied together for this part of the module, but now I want to just show you how the learning environment looks like. So there is a hand menu, which you can select a button from. You can see the Alice particle detector in front of you. And so, for example, the user selected solenoid magnet that sends already a question to GPT. And you can also, I hope you can hear. But anyhow.
Yes, we can.
Ah. Great, thanks, Giacomo. So, but
sorry, we can hear you, but not the. No, sorry, I misunderstood. So we can hear you, but not the video. Actually,
okay.
Sorry about that. Sorry.
No, thanks a lot for that feedback. No, all good. So, since you cannot hear the GPT talking, please believe me, it talks. Yeah, so you can only see the magnet, and you can see some particular question about it and an answer catered to how this particular subdetector helps in studying the anti-helium nuclei. Okay, and this is something that we want to replicate for the ISS model after we have some feedback from the pilot studies, and we will focus on the alpha magnetic spectrometer. And with this, I am very happy to conclude the talk. And hopefully, when we have our end goal, you will keep in touch and you will get to know more about the project as it develops. Thank you very much for your interest, and I'm looking forward to questions.
Thank you, Ash. Do we have one quick question, one or two? Maybe while others are still thinking, I have one quick question. You talked about extraneous load, which also fits nicely to what Patrick told us before, where we can see, depending on how fast a large language model or whatever reacts, people rely more or less on it, which is also related to extraneous load. And one thing that I think could maybe be improved with your interface, we see it here in the slide, note that there's like the logo of the university in the background. I guess that's just how the room that you're using is, right? But I do think this is additional extraneous load built on the students when looking at this model. So I think it would be even less extraneous load if you would just be like in a white room without any disturbance in the background.
Mm-hmm. Yep. Definitely, I think this is something to keep in mind, because the experiments do happen in augmented reality, so you can see the surrounding. And we try to do it in a room where they do not have some extra extraneous load, but thank you for pointing it out. We keep it in mind.
Right, then I think time-wise we should move on, so maybe keep your questions for later. And we now have our last contributed talk from Ali-Dib Mohamad. And I think you can already share your slides.
Yes, can you hear me?
We can hear you.
Okay, perfect. Can you see my slides?
We see your slides still in the PowerPoint mode.
Yeah. Okay. So
Right.
hi. Yeah. So hi everyone. Today I'm gonna be talking about how useful are large language models exactly in computational astrophysics. So I'm going to be focusing on GPT-4 because we published this a few months ago. So it was really before 4.0 and 0.1 and all of that. But I do think that the conclusions we have are still relevant today. So yeah, I'm pretty sure you are all familiar with this kind of plots that aim, well, this kind of tables that aim to benchmark language models, right? So you ask the language model some physics, biology, etc. questions, and then you see how good it is in answering these questions. And you have all sorts of benchmarks, right? You have high school questions, undergraduate questions. However, what we really wanted to do is to see how good are language models, in particular GPT-4, in answering computational physics problems. And in particular, is it capable of writing a computational physics code? So if you tell it, okay, use this particular code base to answer this question, is it capable of generating the code that answers this physics question? And here I'm really talking about PhD or research level questions, not undergraduate level problems. So the paper is on archive since December last year. So we to test the language model's capabilities in generating computational physics code, we used four code bases. We used Rebound, which is very popular in planetary science and planetary science and exoplanets. It's an embodied code, so it's just a gravity simulator. Then we used MESA. For those who are familiar with it, it's a stellar interior physics code. So it solves the equations of the stellar interiors, and it tells you how stars evolve. It's also very, very popular in astrophysics. We use Daedalus, which is a general fluid dynamics code. You just set up a fluid dynamics problem, and it solves it for you, basically. And finally, we use SciPy, that I'm pretty sure all of you are familiar with, but we used it to solve some nonlinear dynamics, so chaotic dynamics problems. So we generated a whole bunch of questions on these four databases. So basically, we asked the LLM to solve some astrophysics problem or physics problem using these code bases. So first, we obviously verified that the LLM is familiar with the code bases, and then we moved on to benchmark. So the way we categorized our problems is, well, obviously you can say you have an easy problem or a hard problem, and this is intuitive, but then we also came up with categories that depend on how parametric the problem is. So for example, you can have problems with no parameters, right? So the LLM does not have to come up with any parameter at all. There is only one answer. This answer depends on no parameters. It's just very, very linear. Then you can have problems with explicit parameters, right? For example, I don't know, if you have some temperature parameter that where the answer depends on this explicit parameter. And then you can also have implicit parameters where we don't tell the LLM explicitly that the answer depend on that particular parameter. And then you have completely out of distribution problems. So these tend to be really, stuff that you're gonna never encounter in any textbook or in any real research situation. For example, a electrically charged planet or whatever. So just to give you a quick example of what did our prompts look like. So we did not fine-tune our prompts. We did not do any prompt engineering. And this was really the point. You can obviously always fine-tune your prompt or engineer it to get a good result on some problem. But the idea was how good is just a generic prompt or how good the LLM is when given just a generic prompt. So all of our prompts just start with use the particular code base to solve the following problem. Then we ask the actual problem. So for example, here, this is a gravity problem with a rebound. We just ask it if we had an extra planet in the solar system between Jupiter and Neptune, what can the planet's maximum radius be for Vesta's orbit to remain stable? You can see it's an out of distribution problem, right? Since we added fictional problem, and then we didn't even ask it about this particular planet. We asked it about something entirely different, which is Vesta's orbit. So this is considered a hard out of distribution problem. So then in Mesa, for example, you can ask simple questions. What is the expected lifetime of a star? But then you also can make it an auto distribution problem. For example, what is the expected lifetime of a star made entirely of helium, right? I mean, stars made entirely of helium don't really exist, except in the post-main sequence sometimes. This is also considered an out-of-distribution problem. So these are not the simplest problems that we asked. Again, we just use a generic prompt, so solve the problem by giving the inputs and the enlist files to Mesa. For fluid dynamics, all of the problems tended to be advection diffusion problems. So you start with some advective or diffusive field, normalized to some value, you add some sources and sinks, and then you ask it to evolve the system and calculate some quantity or stop the evolution after when some condition is satisfied. For example, here we are asking it, how long does it take for this system to reach steady state? Use Daedalus to solve this problem. And finally, with SciPy, it's really Lorentzian dynamic systems. So it's a nonlinear dynamics, it's chaotic dynamics. So these are very general dynamics that are not necessarily specific to astrophysics. So we generated a total of maybe, I think, 50 questions or so, from what I remember. Roughly 50 questions all in all. And we came up with these categories for errors, right? We said we're going to have code errors, which is when the actual code itself had a coding problem, right? Then you have physics errors, which is when the language model makes a physics error. For example, it uses the wrong equation, etc. There is insufficient error, which is when the code is insufficient. So for example, it did not define the time step. It did not define when to stop the simulation. And then unnecessary is just when it adds some unnecessary code that's really not useful or even used at all. And then the pass ratio, so what is the fraction of the problems that the LLM solved for each of the code bases? These really tend to be very subjective in the sense that we did use these categories to see how the models are doing, but at the end of the day, we did have to make a subjective decision on whether it passed really this exercise or not. But basically, the way we come up with these numbers is we ask ourselves, so if a student gave us this answer, would he pass the class or not? Is it sufficient in the minimum to pass the class or not? So all of these caveats in place, the median across all problems, all categories, etc., all code bases, the median pass ratio is 40%. So the GPT-4 was able to pass, not necessarily, with flying colors, not necessarily with no errors, but it gave a sufficient answer to pass 40% of all of the problems we gave. And you can see that for rebound, so the gravity problems, Daedalus, the fluid dynamics, and Mesa, the stellar interiors, the pass ratio is similar. It's around 40%, but for SciPy, it's much higher. So it seemed to be more familiar with general physics problems more than, let's say, specific astrophysical problems. I'm gonna just jump over this. This is just the distribution of the pass and the fail by code base to get to the more interesting part in the last few minutes. So everything I talked about can change, right? We can change the questions. We're gonna get different answers, etc. But I think really the take-home message of this talk is this slide. It's the types of errors the language model exhibited. It's really the failure mechanisms. It's why did it fail on a given problem, and these really tend to be very general. We found the same problems across LLMs and across LLM generations. So, for example, the same problems were in GPT-4, in Claude 3.5, for O, etc. So these tend to be very general. So we found that LLMs really struggle with physical units. So they often did errors in converting the units, but also unit confusion. They sometimes did not stick to the same unit system across the entire problem. And so even when you give it just a change the units problem, it often did not do very well. We found that language models don't handle code versioning correctly, which means that, so sometimes these astrophysical codes just do updates that break backward compatibility, and language models are not always good at dealing with this backward compatibility issue. So sometimes they just call functions that don't exist anymore, etc. More seriously, it tended a lot to hallucinate plausibly named methods and functions in the codes that don't exist, but sound that they might exist. For example, I don't know, in gravitational dynamics, you can, for example, import some function and call it planetary migration, right? Which is something that exists in dynamics, but this particular function don't exist under this name in the code. So they do tend to hallucinate plausibly named methods for this code. Even more importantly, we found a lack of justification for the physical run parameters. So it did not justify its simulation runtime, and it did not even use good values for this, right? And it did not justify the time stepping choice, nor did it use good values for time stepping. It just used some generic values that, you just like throw at the problems without thinking about the physics involved in the problem. And very related to this, the LLMs really were not able to define the stopping, when the physically motivated stopping conditions. For example, how to define steady state, etc. And finally, there is a tendency to use approximate equations beyond where they are physically applicable. So we found these errors really in all of the codes that we tried, even for newer codes. And I think these are really these are fundamental problems related to language models. I did not benchmark O1 extensively. However, while it does seem to improve on some of these errors, so for example, units, etc., it's not necessarily better at defining steady states or not hallucinating submodules, etc. So I gave some examples, but I think I'm practically out of time. So maybe I will just show some more interesting examples. For example, here it defined a time step that's really not physically motivated. So for so this is for the dynamics code, and in dynamics you need a time step that's usually 1/10 of the smallest orbit, and here it used 1/2 of the largest orbit. So it's not really physical, and it's not the code will not converge. Another example, this is in the fluid dynamics code. So it just asked the code to run for infinity. it did not define a stopping condition for the code. This is similarly here in the fluid dynamics code, it also did not define a stopping condition. So I'm just going to conclude with a very simple one-line conclusion, which is how good are current LLMs in solving PhD level computational physics problems? I would say not that well. I mean, 40% pass rate is really what you would get from a bad graduate student, right? However, they do seem to be getting better with a 1, even though they are still not that good. And that's all. Thank you.
Thank you very much. Do we have 1 or 2 quick questions? Giacomo, I think you were the first.
Thank you, Sandra. Thank you, Mohamad, for the talk. I had just a curiosity, so because we have been discussing a bit some of these topics in the past days, and I was wondering, among the flows that you have identified, wouldn't be that most of them would be solved by better trainings, but more accurate trainings, and if not, or if you think there is something specific that is really an issue within the core of the LLM, the way LLM.
Yeah, so very good question. So it's obviously hard to know for sure, but our current understanding, my collaborators and I, is actually it might be more fundamental than just a matter of fine-tuning the model or better training the model. It seemed to be an issue with how LLMs try to model the problems. For example, us as physicists, we learn how to model problems, right? We understand the physics, then we simplify the physics to the simplest representative toy model, then we model the relevant equations, we make sure the equations are useful, and then we check all of the parameters, right? So we are trained to follow a certain methodology in work that we learn throughout our life as physicists, right? Starting from even high school all the way to graduate school. And it's really this modeling phase which is going from a physics question all the way to a physics code, all the steps in between, that I think the LLMs are still not good at. And I think this is more fundamental than just a fine-tuning problem.
Thank you. Maybe we will need to, because I was thinking about the explicit metacognition again, and I was wondering whether we can have multi-agent acting through explicit metacognition and learn from each other and try to mimic a bit. I don't know.
Well, we're actually trying this. So right now we are benchmarking agents on the same problems. So we're gonna see if they do better or not.
Okay. Thank you.
That fits also to what Henry said in the chat, that maybe this all the pitfalls that you observed with ChatGPT can be used to teach students about those pitfalls.
Yeah, absolutely. I mean, they need to be aware of the pitfalls themselves when they are learning physics and how to model physics problems, and also if they ever use ChatGPT, in grad school, etc., which we all do at some point now. They need to be aware of what are the possible pitfalls of the LLM itself. So I absolutely agree.
Well, thank you very much. It's time for a break. We have a 15-minute break. We will need to continue at 4 p.m. To be back on time, basically. At 4 p.m. we have an invited talk again, more from the psychology perspective by Ella Glikson, who I think also already joined us. So hi, Ella. Go take your break, 15 minutes, and then we'll continue at 4 p.m.
Very good. Thank you, Sandra. Just to remind to everyone on Zoom, since we are broadcasting on YouTube, and I will leave the streaming going on. So maybe you want to turn off the camera and mute the microphone. Otherwise, you will appear for 15 minutes on YouTube, basically, just for privacy. Take your time, take your break, and we'll be back at 4. Thank you, Sandra. Okay, here we are. I think we can slowly come back. Hi, Ella. Hi, Sandra.
All right. Yeah. Hi, Ella. Thanks for joining us today. We already heard one talk from cognitive psychology today at the beginning of the session from Patrick Weis, and we will now hear your talk, and we're very curious about it. I will just briefly introduce you. So we have here with us Ella Glikson, who is a professor at I'm not sure if I can correctly pronounce that.
Bar-Ilan University.
Bar-Ilan University in Israel. And you've been researching different aspects of human technology interaction, human technology teamwork, also trust in AI, I think. And yeah, we've been hearing a lot about this past days at this conference about the use of AI and large language models in astronomy. And of course, whenever we use AI, we also have the human perspective. And we're now very curious to hear from you about AI-mediated communication. So please go ahead.
Thank you so much. Thank you. And thank you, Giacomo, for inviting me. I have no knowledge about astronomy, so I'm very excited being here, learning a lot. I'm an organizational psychologist, so my focus is on human-to-human interaction and how AI changed it. And my biggest idea today is to evoke your awareness about things more than anything else, because we are in a very rapidly changing world and we need to know what's happening. So first of all, I will try to explain to you what is AIMC and why it's important to know what it is and how to deal with that. So artificial intelligence mediated communication is actually interpersonal communication between humans, right? In which we have this intelligent technology that operates on behalf of us, on behalf of the communicator. And it does it by modifying, augmenting, or even generating messages to accomplish communication goals. So basically, communication goals are ours, but the way that it's happening is something that is mediated through AI, and versus the Zoom in which you actually see me, I could put an avatar, and avatar could, use my language or could use its own language and admin all kind of additional things to the presentation if it would like. And it's already happening because we do use a lot AIMC. So I'm just going to give you some examples, but I'm pretty sure that each and every one of you are already using a lot of them. So I hope you will find yourself. And if you have another use, please do tell me. So first of all, we do need to sometimes improve our spelling and grammar. And I use it a lot for my emails, but I don't know. What about you? I think that especially for non-native English-speaking language countries, this is very, very common use to save time when we are replying to emails, right? When we need some suggestions after replies or sentence completion. And even when we need to translate text communication from or to different language, so we use machine translation. And again, if you have any other ideas on how you use it on a daily basis, please do let me know. I would love to learn about that. Basically, we also today use large language models to generate entire messages on behalf of us or on behalf of the organization. And we do it very commonly, especially if this is something that needs to be formal or relates to some topic that is more general and less personal. So if in the past we looked at communication as a process in which we do have a noise, but we have sender and we have receiver and we have encoding and decoding messages, now we have this artificial intelligence agents that are actually helping us, and I'm going to say helping us, but they're intervening in our encoding, but also intervening in our decoding of information. For example, if I'm receiving message in language that I'm not very proficient at, I can definitely ask ChatGPT to explain to me what it meant to make sure that I understood it correctly. But this is not the biggest problem, because here the most control of what's happening is still in our hands. What happens in the very near future is that basically AI-mediated communication is going to be everywhere. It's going to have much larger impact on everything that happens within communication, because when I am writing message and I have this information may be most probably came from another communication that I already received that was moderated by AI. I myself have a lot of my perceptions, my behaviors are impacted by AI, such as, let's say, self-efficacy. To what extent I can write or present things in a language which are not my native. If I know that I can use machine translation and it will be able to, and it will help me a lot to translate things easily, right? I will feel much more easy to go and do things that otherwise I wouldn't. So it might impact my self-efficacy. It might allow me to do things that I would never do before, but it has an impact on what's happening to us. So for now, we are using AI individually, right? As people that it's actually our choice to use it or not to use it. And in the very near future, what's going to happen is that just as, organization decides whether you're going to use Zoom or Teams or whatever, organization is going to have some more control over the specific AIMC that we're going to use to style the message, to adjust organizational values and beliefs. So, for example, one manager can say, you know what, we don't want any negative affect in our organization. So please do use this software that's going to just make sure that you are not too negative. So maybe it's not going to exactly tell you that you are overly negative, but they're going to show you a little emoji that's not going to be very happy. So you will understand by yourself that they need to make it more positive, for example, right? Or if you need to translate a message, for now, like I am corresponding with the person who's in Italy, and sometimes I get emails which are in Italian, and I have no idea, like I don't know Italian at all, but it translates to me the emails automatically without even me asking me whether I need it or not, because it knows that those are my foreign languages. So I automatically let us a message in a different language. But also, if we need to communicate important messages via various media platforms and we are too lazy to do that, copy paste and stuff, so we can use AI to do that automatically. And organizations are highly tempted to have these abilities and to use them. But we need to understand that there are a lot of possible psychological implications of even access to this technology, not only the use of it, because the way that we interpret communication, it's very different. The way that we perceive the message, the way that we perceive the communicator. For example, if I'm writing a very convincing English email in English, right? You think that I'm proficient, right? That I know this language, but maybe this is not me writing to you at all. So the perceptions of me are actually not of me anymore, but of my ability to use artificial intelligence to actually compose this message. So this is something that we need to consider, perception of the self. Again, to what extent I feel comfortable or confident to do certain things, knowing that I can use those tools. And also, of course, it might have great impact on learning and behavioral intentions. And this is what we just start trying to understand. So the one biggest question, and this is a concern more than anything else, is to what extent we can know that AIMC is being used. And for now, we can't, because the use of AIMC is completely invisible. No regulation, no demand to acknowledge that it was being used. And this is a very, very huge problem, because as technology is being more progressing more and more, there are a lot of deep fakes. And I don't know if you have seen those videos in which you can see people that you know, and they say things that they never actually said, and you cannot really see or realize that this is actually fake. So one of the problems is that if there are not going to be any regulation, and I call you as researchers to actually voice your concern as well, because our voice is not very strong, to make sure that this regulation is going to come, because otherwise either we're going to lose our trust in any type of communication that is mediated by technology, including phone calls and Zooms, because everything can be faked, or the concept of authenticity or truth will be completely changed, and it's gonna lose the meaning, because so far it's very important whether I am authentic and whether you can trust me and whether you can see me as a human being. But in the future, maybe this is not going to be even a problem. So one thing that we can do about this is to see what's happening if I'm telling you that I'm using AIMC. do I pay price for that? Or do you like it for me to disclose it? Because as long as there is no regulation, there needs to be some other mechanism that can help me to understand whether this is me who's writing the message, or am I using some help with that? So we know that, especially when we talk about translation by AI, people have a lot of doubts, especially because a lot of translation in the past was highly not accurate. And one of the studies that we did some years ago, wow, it was like 3 years ago, so it's very, very old. It was received like, if you show the same text to a person and you say this was translated by a human being, or you compare it to the same text exactly, but you're going to tell them that this was translated by a machine, they think that the text, if it was translated by a machine, it will be less accurate, less reliable, and then it would be less effective in making the message. So we know that this bias was there 3 years ago. I don't know to what extent it's still there, but it might. And our recent results kind of support this. So still, there could be a lot of benefits in disclosing the fact that I used AI. And the research again tried to look at those benefits. And one of them, they saw that, well, if I'm making a mistake, if I'm doing something wrong, then I can use AI as a scapegoat. I'm gonna say, well, you know what? This is not me. This is AI. I used AI translation, so it was wrong. And I already had students using this excuse, although they didn't declare that they were using AI before they realized that there was a mistake. But then when I said, well, this is wrong, this is not my fault, this is AI's fault. So the moment that we can, that something goes wrong, actually using AI can be, declaring the use of AI can be useful for this matter. But also, it might hinder trust. And it also might hinder the perceived competence of me if I'm going to tell you that this is what I'm using and this is not me writing, but this is something that I used AI for it. And there is some evidence for that based on the past research. So what we were trying to see is to understand that, to try to understand what's going to happen if I'm going to tell you like directly, look, this is not my native language. I had this message and I used a machine translation to translate it. So this is like being done by AI. To what extent it's going to be something that is going to make me more competent in your eyes or not? And if it is, then okay, we should just acknowledge using AI, right? So this is a very good thing. But if it's not, we just need to know about this and understand that we need regulation. So this was our motivation in doing this study. And the study was published in 2023, which means it was done before that. And it's my work with Omri Asher, who is also in Bar Ilan University here in Israel. So I'm going to tell you about the research because I think that psychologists are very, very lucky to have the most fun way of testing things because we look at the actual people and how they behave. So we had this context of international organization that is uses many languages and work with people from different countries. This organization has had heavy dependence on technology. And there was one worker that needs to use a foreign language for work. He was from some Asian country. We didn't say exactly which country, but his boss was not, and this person needed to communicate in English. And we know that, in this type of organization, as in academia, there are some misunderstandings and conflict because of the cultural differences and the geographic dispersion, so it happens. So our context was apology because apology is a very strong and very important concept that in work, but not just in work, in any type of interpersonal relationship, it's a very important mechanism to work through depleted trust, to improve communication, to improve collaboration, to get people back together. So it is very important that any type of apology is being perceived as sincere and authentic, right? So we will accept it and we will be able to actually restore trust. So this is what we tried to do. We told people about, we gave them a scenario. I'm going to talk about the scenario shortly. And we wanted to see what happens if this person is apologizing by himself, although it's not his native language, or uses machine translation to actually apologize. So we conducted 3 experiments, and each of them have different role and different purpose. So the first experiment was very, very easy. We thought about this person who's located outside USA, not proficient in English, but is high performer. However, he missed some deadlines, and this something that was hurt team evaluation. So he did something wrong, and he writes an apology to his boss, and the apology is very convincing. But then we, as researchers, as experimenters, tell our subjects whether this person used or did not use AI-MC tools for translation that are provided by the company. So either this message was translated but was written by this person, or was translated by AI-MC tools that actually company provides. And then we asked the participants to what extent this email looks authentic or not, to what extent, which is the most important part, they are willing to forgive this person and to, to take it as a trustworthy apology. So you can see on my slide that actually the different manipulations. So what we found is that perceived authenticity of the apology was much higher, significantly higher, when there was no statement of using IMC rather than when it was using IMC. And this is something, this information we provided by the experimenter, which told them very explicitly that this is what's happened. And this had downstream effect on the forgiveness. So if I think that this is not a sincere apology, I'm not going to forgive this person, right? Makes perfect sense. But then we went, a step forward, asking the people, okay, I understand what's happening, but what happens when I am telling you that I'm using AIMC? Because this is main issue. Usually we don't know if people use it or not. Now I'm telling you, to what extent it's going to buy me something, to what extent might make my apology even more sincere than if I am using AI. I'm not telling you about this, right? So this was our motivation, and this is what we were hoping to get, but this is not what we get. Because what happened is that whether I am telling you that I'm using AI or experimenter tells you that you use AI, it doesn't really matter. It goes and the authenticity goes down, and then the forgiveness as well. So this is not something that protects us. This is not something that we have high motivation to do. And this is even more concerning to me, because if this is if this is what we find, it means that we have no actual motivation to use it unless we're wrong, right? So this means it's even highlights even more the need for regulation that will make sure that our use of AI is actually being acknowledged, okay? And then there's another issue which is highly important, and somehow people not really using understanding this issue as much. Just as any type of AI, AIMC affordances is not a yes or no. Do I use AI or do I not use AI, right? I can use AI just to make sure that I'm not making any type of orthographic mistakes, right? Is it the same as I'm letting AI to write my message? Of course not, right? And especially if I'm letting it to actually read for me whatever it actually thought that it's going to be for this presentation. So we are talking basically about the continuum, something that starts with nothing and ends I don't know where, because we're not there yet. But if we understand this ability as a continuum, as something that is building upon each other, we can actually make a lot of sense of what's happening. And we also do not have to say, well, I'm not using AI at all. We can say I'm using AI at a moderate level. I can actually decide what level of reliance of AI I'm going to have. And this is highly important, because this is something that we can also appreciate. Because if I have the ability to actually build the entire presentation by AI, but I'm not doing that, and I'm doing this by myself, you're going to respect this much more than if I am using it all of it, or even just part of it, right? So this is something that our psychology is very responsive to, and I think that this is definitely something that we can use. So in the third experiment, we actually said that this person, he was able to use 3 tools that are doing the AIMC work, the translation, language correction, writing assistance tool, but he used only one of them. And we played with which one he used. So we had 4 conditions. And when we looked at this in this way, we actually had very different effect, right? So if you use all the AI tools, this is very different than when you use this intense use of AI, when you use only one of whatever was available for you. So people do appreciate us limiting ourselves of the complete use of AIMC for communication. And this is, I think, a very important lesson, because although our full disclosure is not very evaluated, when we disclose that we are use only partial of the, part of the tools that are available for us, we can actually make a difference, and then we will be perceived as more authentic and will be forgiven for the issue of apology, but overall it gives us much more credit. So instead of saying don't use AI or don't disclose using of AI, I'm telling you, please consider AI as many different affordances that it have, and disclose the level to which you do use it. And I am telling this to my students, and hopefully they will use this device. I don't know yet. And nevertheless, it doesn't say that we do not need any type of regulation, because at some point when 2 robots are talking to each other, right? When 2 AIs are talking to each other, it's not human communication. And we are very close to get to the point in which emails that being exchanged are not even being exchanged by us. And, maybe we don't even read it or understood what's happening there. They are all being generated and interpreted by artificial intelligence. So I don't know how much time I have, because I'm really running through it, but I really do hope to open this for questions. So I'm just gonna make the conclusions. Acknowledgements of using AIMC tools hinders authenticity. So it creates a distance between the original intention of the writer and the message. And this is not very good for us, because it means that disclosing doesn't really help. Result of lower perceived authenticity, the effectiveness of the message is hindered, and it leads to lower tendency to forgive in the case of apology. But nevertheless, when we use not all the AIMC tools that are available to us, but only part of them, and this is something that can actually assist our perceived authenticity and then whatever behavior that we are hoping for. So overall, we need to understand that no matter what field we are at, AIMC is here. And it's on its way to organizational communication. And as much, the Zoom is now part of our life, AIMC is part of our life as well. And it's going to be much more intensive in a very short time. And we have to have some regulations that will tell the other people, our communicators, to what extent our texts are being modified. And not just whether they are modified or not, but also to what extent they are the extent of this modification. Whether I just used it for correcting some wording, or I used it to generate the text. And it's very important and meaningful. So now you will tell me to what extent it's actually relevant to you, because I think it's relevant to everyone, because we all are there. And I can talk about other things that are relevant to this, because it also kind of builds our self-efficacy and does a lot of other things. But those were the main issues that I wanted to share with you. So I would really love to have some questions and to make it into conversation.
Thank you, Ella. Thank you very much for this interesting talk. Yeah, I think we can open the floor for questions, maybe first directly to Ella about her talk, and then we can also open up the whole round of discussion. We have a hand raised by Dario. I think you're able to unmute yourself. Yeah.
Yes, I'm able to unmute myself. Very, very interesting. But what for me, from your talk, I see a lot of assumptions that you make, like, for example, that is good to accept an apologies instead of better of accepting an apology. Or you assume that is good the trust instead of better the trust. So so there are values, Western values, that are embedded in your research. And my thinking is we are in a world in which there are several cultural bases in which not trust maybe is not so important, or more important, hierarchical acceptance. But what it makes the difference? Why should we have regulations? Because you say I want trust, but why do you want trust? Is it maybe blocking us? And this is I'm referring also to the debate that is now, like, Europe is regulating, US is innovating, and China is winning. So where are we going into regulating to block ourselves, to change ourselves? And are there other, there are many things that I could ask.
No, definitely. But the problem is that our agency as humans, right? Because we are as humans have our own agency, and the question is to what extent I can trust that the entity that I am having this conversation with is actually a human being. There is different question to what extent it's important. I think as a psychologist that this is very important, but not everyone's going to agree with me. I think that the trust that can be broken totally is between ours, like, to what extent we actually can communicate using any type of technology, assuming that we are communicating with a real person. And it's not just a person, but actual human being who is Dario Doriga, not someone else who just uses his name. And for interpersonal communication, especially, and across cultures especially, this is a very important factor, because if I cannot trust that this is communication is sincere, is authentic, I will not be able to share some information with you, and then it's gonna be just a loop that's gonna go in a very negative direction. So yes, I use assumptions, but I really do hope that we as humans are not as bad, and we should use technology to improve and not just take our agency away from us. Thank you.
Maybe also to just quickly add on this what Dario said, because I'm also researching trust in AI and robots, and I think that you're completely right that high trust is not always the good thing. What I would say is that it's correctly calibrated trust that we need. So we need to trust the technology for what it can do, so that we can indeed use it effectively and to become better at our performance. But we of course should also be aware about things that we cannot do. And there have been, for instance, very harmful incidents with self-driving cars where the technology was over-trusted. And then instead of staying attentive, people were playing on their phone and they couldn't step into when a crash happened. And I think that's a very crucial point where we have to look at.
Absolutely. There's also a very big issue is about our knowledge acquiring, our learning, because when we have this over-relying, we might actually have this Dunning-Kruger effect in which we decide not to keep learning, not to acquire new knowledge, because we think that this knowledge we can have externally, right? We can use whatever is there for us, and it's also very, very dangerous.
I think we have a question by Patrick.
Yes, thank you. So I find it interesting that this perceived authenticity is low when using IMC. Now, you were researching perceived authenticity, and I was wondering, what about actual authenticity? So do I put less effort into my apology when using AI? I do so. The question is, I guess, when people perceive it as having lower authenticity, is it justified or not? Do you know?
It's a very good question. I do not know, because it's okay. So the way that I'm looking at authenticity is the difference, the distance between you and your words, right? So you can be not very authentic in anything you do, right? You can be like genuinely unauthentic person. You can, and this is completely your right. The problem is whether I'm thinking that you are not authentic because this is who you are, or just because you're using this tool, right? Because you can be inauthentic in many different ways. The way that this intervention in the communication gets in is that it actually pushes you much further from me than you would be when you would use your own words. So like say, think about expressing emotions, right? We look at the emotions, very important for us, whether you actually feel something or faking it, right? And we actually kind of good at identifying the fake emotions versus the authentic emotions. If you use software that makes your face smiling no matter what kind of actual emotion you're feeling, this is very different. And then I cannot even trust my own perceptions of you because of this, right? So, and this is huge because evolutionary, we were building to look into those cues because those cues are highly important to us. This is how we decide whether a person is warm or not, whether it has good intentions or bad intention, whether he's competent or not competent. And if those tools are taken away from us.
Yeah, I mean, I agree. I think the only point I wanted to make is that you took a look at the receiver of the apology, but might also have an effect on the sender of the apology.
Of course, I agree.
Thank you.
Totally. Sure. Thanks. Yeah.
Yeah, come on.
Yes, thank you very much. I'm really fascinated. Ella, thank you very much for the beautiful talk. So I wrote down so many millions of questions and points that I wanted to. But let's start from so the role of AI MC. So basically there is a context in which, for example, when I want to start in education, for example, so just following what the Aish showed us. So that when I want to study something challenging myself, for example, I see that it's easier for me if I do it in my native speaking language, as you said, because it removes the effort to make a translation sense, right? So, okay. But on the other side, the language is a vector of cultural content. So what I mean, if I communicate something, I was wondering, what is not possible that if we use too much this machine active, so AIMC, that we end up canceling basically the cultural differences, and so making, is the end of the Italian identity, for example, and you see what I mean, and of yeah.
I think that as well as because our communication is not only mediated by technology, right? We go home and we still speak our language and we still have those communication norms, and it's not canceling those norms. It doesn't cancel our culture. It creates some kind of a little bit fake illusion, or not fake, just an illusion that we understand other people better than we actually do, because we now can read anything in our own language, right? So it kind of like, and now ChatGPT can actually make your message, whatever it is, in another language, being adequate to the cultural norms of the other language. So if you are in any country that actually has a lot of respect for their elders, and you need to write "Dear Sir," even if you're not using this, AI can actually help you to be adequate to the other people's cultural norms. But it doesn't definitely makes you more knowledgeable, or it doesn't, you are being perceived as being more knowledgeable without actually having this knowledge. So it's a very tricky issue. And the most important part of it is that we must keep learning and acquiring new knowledge, because otherwise just relying on the technology will lead us to many very interesting illusions and associations that have AI and not us. So
Good. Thank you.
Sure.
Fabio?
Yes, probably you just answered. because I was very confused by the conclusions, because on the opposite side, so in our environment, AI MC used to remove biases, cultural, language biases. So at the end, the problem is that if you are evaluating the person or what they do. So if we have to evaluate a paper, I don't want biases. I don't care who is writing what. If I'm hiring a person, then it's a gray area. So that I must admit. If I have to evaluate the person, then I agree. I think AI in this context is like photoshopping your picture in a dating app.
Yeah, thank you,
Do you
Fabio.
trust that?
I think so this is how AI-MC is a little bit different than just AI, right? Because although paper is type of communication with a larger audience, you don't want it to be adequate written, right? You do want to have nice wording, and this is why it's so tempting to use it, and I use it a lot, but there's a very big difference than use it just to improve your own language and your own words, and then use it to generate ideas, right? And I already have seen this as well. So behaviors and people are connected because we learn about person based on their behaviors. And if this is too much moderated by technology in a very large extent, we don't know yet how to deal with that. We don't, because this is how we learn about other people, by their emotional expression, by their words, by their actions. So if it's broken, I don't know exactly what's going to happen. On the other hand, on the positive side, because we don't need the positive side, right? It definitely makes more the access to better writing and understanding much more democratized, right? Much more people now can make papers at a very high standard that they couldn't because of the language barriers. And now much more people can work in multinational organizations than ever before. And now more people can even study ancient history, that before that they had to learn languages, dead languages such as Latin and Greek and etc. And now they don't have to learn them because the translation is embedded in so many things. So it does open a lot of doors for many wonderful things, and a lot of barriers are getting much, much lower. And nevertheless, there are some issues that as psychologists I cannot ignore. So I'm bringing it to you to, think about and consider as those things are definitely going to develop and be more and more profound in our daily life. And by the way, there is already, I was at the conference, I already heard a lot of stories about people being interviewed and then coming up to work, and the person who was interviewed and the person who came to work were kind of different people with regards to their skills and their abilities to do things. So it's already in movement, it's already happening. And we need to just know about that, right? Try to think how we make the best of it.
Thank you. I would like to open the discussion for everyone. So maybe if you could not share your slides anymore, Ella, so that we can see each other more easily. And if the speakers of today would like to turn on the camera, you're welcome to. And then, yeah, I think we can have a chat all together, and you can ask questions the different speakers. Maybe to start with, I would like to pose a question that kind of also falls into what Ella was talking about. So what we heard now is that, but also fits a bit to what Patrick was talking about, that our beliefs are strongly related to using those tools or to perceiving these tools. So as Patrick laid out, we might use a tool more or less depending on what I think about the tool, what I've learned about the tool in the past. And Ella has also shown us that we might trust information from AI tools maybe less than we trust information from other humans. And I wonder whether in the future, when we try to look ahead some years, and I know this is very, very difficult, but if we just try, and those technologies become more and more sophisticated, way better, whether this might actually turn around so that we start trusting AI content, for instance, more than content of other people. And whether this, for instance, could also happen because, as Patrick said, we are communicated that certain AI tools are superhuman and have like superpowers. So could it be that we actually then see the reverse effect of more trusting computer technology generated output than human generated output? And whoever wants to say anything about this, feel free to step in.
I could definitely see this happening because even now, when when you have to talk to someone who's expert, it's something different than if you talk to lay people. And ChatGPT is so much more knowledgeable than people that have no expertise in some fields. So we definitely will and already are relying on AI for many issues, and it's going to be better and better in many aspects. The problem is that if we are not experts, we can never know to what extent it's right. So I think that, again, there needs to be some mechanism in which we're not going to be over trusting. So
yeah, I would probably also lose some words. So I would definitely agree that we might trust technology more than we trust other humans, just based out of performance reasons, which is, I think, a good thing because we probably improve our performance as a society in a good way. But I think it's quickly getting a philosophical issue where the question is, how does the human get into the equation? So that we also like somehow contribute to society with and find our niche where we can contribute. And so I don't see necessarily the problem in trusting AI when it's actually good and we can agree that it's good and is so transparent that it stays good. But maybe for me, the challenge that I see is more like finding the niche for the human.
Yeah, cool.
Yeah, I was just maybe for Patrick, because you used the word to you say, I think not progress, but to that. Now I forgot. So you use the word of progress of a society, or to improve society, and I was wondering which metric are you? So in which way we are progressing? Which KPI do you use for that?
Yeah, tough question. So I was referring to like some performance output that you can measure, like, I don't know, knowledge gain about the universe. I don't know, like that would be like a kind of objective knowledge or performance gain. Yeah. So that was what I was referring to. Obviously, you can have other metrics like emotional well-being of humans, but yeah, I was not referring to that.
Well, for example, the perception of self, that Ella was mentioning in the talk, how this will evolve. So we will become less self-conscious with time as humans, as individuals.
I will just like throw some words in there and then give the word to other people. So from what I know, sometimes in this direction, sometimes in that direction, there is some research that will say that, well, you feel small in comparison to the big human AI helpers that are everywhere, but then you can also incorporate them into your self-image and be like, yeah, I am powerful together with AI. I think it's maybe a matter of perspective. And if you can see the AI as your friend or like close to yourself or you're in group, maybe you're doing well. But if you see it as a competitor or something that like a corporation owns that you don't like, maybe you're in trouble. That would be my take on it.
Thanks.
Dario?
Yeah, for me, it's also interesting. So I see Aishwarya, so for the authority issue, because when a professor or a teacher comes to students and says, "Okay, music also AI," then are the students trusting the professor, or do they think, "Ah, no, but it's AI," but in reality he knows like me, and so I don't trust, and I don't feel that I need to be in contact with this person. So is it lowering the authority of the people?
I think that's Dario, thanks, but it's very interesting actually. And a lot of education-based studies are trying to figure this out, if it in some way is replacing the traditional educator, if it's lowering their authority. But I think at least so far, it's not, the LLM models are not so superb that they can make everything by themselves. And then there is a very good balance of the educator being an ally to the AI tutor, like what Patrick just said, because you need to give the so I work mostly with GPT. You need to give it context. You need to tell it to stick to this particular task. And in this sense, at least you are very much a part of it. From the student's perspective, on the other hand, we could maybe see that happening, but I think having a human present in the classroom as this learning interaction is happening is already a great benefit for the students, because there's a lot of social interaction involved in here. I'm not a psychologist, but even cognitively, I think they would feel very much for them in that sense. But I give it to the psychologists to say if they do not agree.
I think we're getting into a point, not yet, but sometime soon we're gonna get this augmentation when AI is gonna be part of our knowledge. It's gonna be like integral. Like some people feel that the iPhone is part of the hand, or I don't know. So we definitely might rely more and more on AI technology. So it doesn't have to be competition. It's just something that we can use. But on the other hand, it's external knowledge. Even if we're going to have some kind of device on your ear or whatever, it's still external. And I think that this is not going to change. And whatever human has as without relying on technology is still going to be valid and important. And the agency of a human as human, as well as its literacy and ability to use AI. Because as AI going to be more and more complex and more adopted into different situations, our ability to use it also going to be a very important factor. So we need to know how to use it and when, and in this way to separate the good things and less good things.
Yeah, come on.
Yes, I thank you, Sandra. I was wondering, so can we, in order to understand because one of overall, I think I feel that one of the points that is interesting to understand is what's the consequence of using this technology that it was told we saw this. ISCOM is there, so we need to understand and use them. But I was wondering, can we make so basically have help, so in order to be helped to understand what the consequence will be, whether we can make use of the experiment or the experience so far done with the impact of some technology in our life. I make an example: the entrance in our life of internet, cell phones, social network. I mean, the way this changed so far our society. In a sense, I put it, I name it society. I don't know what's the technical, and whether this can tell us because the way I see AI is kind of speeding up some of aspects in learning, in interrelationship, into empathy among each other, and this has been affected. This is my opinion. It's not scientific. Okay, it's my opinion. It has affected already the way we interface to each other, and I was wondering whether we can use this to predict what the future will be.
I don't know about future, but I'm sorry, I have to like jump in because it raises very important difference between technologies that we had so far and AI. One of the very interesting differences is that the richer technologies that we are using, the more we feel closer to each other, the more we reveal of ourselves. For example, video conferencing is much more revealing than email or chat or whatever. AI does completely the opposite for communication. The more we use it, the less we are agentic to ourselves, the less we are true for ourselves. So we definitely can see, you know, how organizations took into all kind of technologies and how we adjusted to this. But this is a very important difference that we need to consider because it changes the very big question of like who we are as humans. So I'm just putting there and
I think Aish wants to contribute to that.
Yeah, thanks, Sandra. It's a little bit hard to follow up with that deep thought that Ella just put on the table. But just to add my perspective from the education side, I think I don't know how to say what will happen in the future, but what I do know for sure is that a lot of things point us to the fact that we need to prepare. And so solely from the education perspective, we've seen through various empirical studies that teachers acknowledge that new technologies help in education. They do help, the students also enjoy it more. And that's the same, I think, for us at this point, to really understand and prepare with this technology to be able to maximize its good and minimize the bads, I guess.
What I'm also thinking about this, it also obviously really depends on what you use the technology for, right? So when I think about the example with the augmented reality that I showed us, I imagine this being a big addition for the students because they can either use that, right, or not see this technology at all because they cannot all go to CERN, right, and look at it. So that's just impossible to experience anyhow else. Whereas on the other hand, when we look at Patrick's calculator example, if kids, instead of learning how to multiply, you know, this, I don't know, at least in Austria, we have the Einmal-Eins thingy where you just learn how to multiply. And this is just something you learn by heart as a kid, or you learn the theory, how it works. But if you just never learn this because you have already as a 6-year-old your smartphone and you just use that all the time, that's of course like very problematic because then later on also more difficult, mathematical operations will be more difficult. So I think we will also need to be careful with for what is it useful and which task we should really aim at relying on ourselves and training it also with our cognition. Yeah. I think Fabio was maybe first, but then Patrick.
Patrick, go ahead because maybe I'm drifting a bit, and you might want to answer.
I'm not sure if I'm drifting less than you are. So I just want to throw another concept in here that might help answer the question where we want to head at society, and that's the level of analysis we're looking at. Because so historically, as cognitive scientists, we very frequently only looked at one human being. So how good is human A at performing a task? But now, with more and more technologies, the question is, should we use a different level of analysis? Should we look at human plus calculator, human plus computer, human plus AI? Should we do that? Or should we stick to the human being? Or should we go into a societal level and see what we can achieve as a society? And I mean, at least in Western countries, like an individual is very precious, right? He has to be able to perform. And now this might shift when we use AI, or then should we stick to the human plus AI and see what an individual plus AI can achieve? I mean, I don't know. I just want to throw this unit of analysis chain of thought in here too, because we need to figure out where we want to improve, on which level we want to improve.
Yeah, that's, I think, a very interesting point also within intelligence research. Intelligence researchers spend many years developing intelligence tests to figure out the IQ of people, so the intelligence coefficient. And now, of course, intelligence researchers are also thinking about, shouldn't we, instead of just assessing a person's IQ, assess their IQ while using their smartphone, for instance? Because this is just more like ecologically valid, because that's actually what we do on a day-to-day basis, and also in our work environment. I think these are very interesting questions. Fabio, now.
Yeah, that's another very hot topic, because we don't have the definition of intelligence, so it's difficult. No, I was afraid I was drifting because I need a psychologist. In the sense, I have a general question, slightly moving toward the technical side. So personally, when I interact with an AI, so when I'm using a chatbot, I always please and thanks when I ask questions. So I'm rationalizing, saying that I've seen that movie, The Terminator, so I know what machines can do. But the point is that, so first of all, does it work? Approaching in a polite way. I have no idea if there are research in that sense, but for me, a language model, I see the persons behind. So I say, please, can you answer this question? Because they know that trainers were of a certain type. So maybe they were educated to use the magic word please before, so it becomes natural. And just a comment to Patrick's presentation, I would trust more a language model for topics related to social skills because of this, because there are humans behind. And I see trainers, so humans behind the language model, just because language is a human thing, not a machine thing. So the basic question is, does it make sense to say please and thank you to a machine?
Can I jump? I have to. I'm sorry. So there's when I was studying the trust in AI and the past studies that have done on this, one of the questions that researchers were amazed to see is that a lot of people were not just playing with AI, but actually trying to insult it and to test its boundaries and say very bad things about, robots and stuff. Because one of the things that happen is that when you communicate with the LLM, ChatGPT, whatever, you don't feel that you're talking to machine. You feel that you talk to human, and you humanize not the people who were developed it, but even the computer itself, the program itself that you are communicating with, because it is programmed to be very human-like in its communication, and also very polite, very straightforward, very confident of itself to the level that, So I'm sorry to say this, like 50 years old male who has white male who has all this confidence in the world that he's right and this is what he does. It's a good thing. So we anthropomorphize. We can anthropomorphize any type of technology, including ChatGPT, and it's very easy for us. And it was developed for that. And as you know, there is a lot of things about Alexa and how it was sexually even, abused with wording and everything else, because people were feeling that they need to understand to what extent it's human or AI or something else. So we are human, and we are, and our reaction, our behaviors are completely human. So I'm really happy that you are very optimistic about how all of this is going to be there for us no matter what, and how we will be able to rely on this technology. And you're not afraid either from, with the climate changing or whatever, and that we always going to have an electricity and internet and everything else that's required to sustain those technologies. So I'm very happy to hear that. But still, I'm thinking that as with a human with a smartphone or human with ChatGPT is still a human that uses ChatGPT, and it might use ChatGPT in different ways. It's not embedded in the ChatGPT the way that I'm going to use it. Even though I'm taught all kind of prompts, the way that I still have the power, the agency to use specific prompts to get what I want. And this agency is highly important. And it's not just the technology, it's also the way that I am using it. And I think that this is still have a lot of it still gives us a lot of will and a lot of power to, make our world the way that we want it and not the way the Terminator is living it. So.
Patrick?
Yeah, I just wanted to contribute my gut feeling about the initial question about whether you should say thank you when communicating with AI. Well, my gut feeling is somehow yes, because I would assume, and Ella might know more, that there is some spillover effects. When you're just not kind to AI, and the next you're talking to a human, I in it maybe also more inclined to be not kind because you just were not kind to AI and got the knowledge. Maybe you're also getting the knowledge from a human without being kind. Or is it maybe just costly to switch forth and back between kind and not being kind? Because then you're talking to an AI, then to a human, and just switching forth and back between not kind and kind. Maybe it's just easier to always be kind, right? Because else you have those switching costs, and maybe you have a negative spillover effect. But I don't know if there's any research to this sort of spillover of kindness or not kindness. I don't know.
Also, maybe just to add on this, I'm not sure what the current status with prompt engineering is, but like a year ago or so, when I did a workshop on prompt engineering, the status was that one should use such more or less human cues. If you ask a human to do something for you, it's better if you're very nice, and then you get a better answer or better performance in return. And at least a year ago or even more, this was also helping with a LLM output, that if you gave cues like, please do this, this is very important, take a deep breath before doing it, this increased the performance and made the output more correct. So I think maybe from that perspective, in addition to what Patrick said, it might also help maybe. At least I think it probably doesn't cost much, because this please and thank you is something we do quite automatically, or at least I do it automatically. Yeah.
I don't know enough, but probably statistically, it's more common to see phrases like "pass me the salt, idiot," and sorry, pass me the salt, please, then pass me the salt, idiot. So
could be yeah, come on.
Yes, sorry. I want to just say something related to what Ella said. The way we use, not the fact. So, okay. But so first of all, I'm not as positive as one may. I'm in the negative side, just to let you know. So not the positive, unfortunately. I see very many risks more than benefits for now. Okay, but on the other side, I also think. I feel, again, it's a feeling, I don't know, but I feel that it is not really true that is the way in which you use technology, but it's the use itself that can be dangerous. I make an example. In my opinion, the use of social network and the impact of that can have on an empathy or growing empathy. It does not depend on the way you use the social network, but it's the fact itself that you use it that will somehow change your empathic capabilities. So that's not bad. And I fear that the same there is, of course, there are benefits when you use certain tools. I mean, I can communicate with people that are far away, and I can connect with friends that otherwise I would never see. And this is beautiful, I say. But the use itself does have consequences, regardless the way I use it, in my opinion. And it might be that also AI and GPT on these new technology that are coming will have consequences no matter what. I don't know.
May I jump in, because I think this is also connected to a question from Henry in the chat, saying that asking if we have to use it. So maybe we don't have to use language models. So, well, what I learned today, I think it was from Patrick, that we human beings try to maximize the energy and minimize the consumption of energy. So we choose shortcuts. There's no way out. So if we can sit down all the day, we do it, and we lose the capability of walking. So if we have a tool that improves our possibility, we will use it. There's no way out. So you can be pessimistic, but we have to deal with that, because some things, some aspects of our life are improved by this tool. There's no way. Can be abused? Yes, of course, can be abused. Personally, I had many more interesting conversation with a chatbot and deep conversation than small talk in the pub. The temptation to talk only to AI is strong.
I think that's also a very, very interesting point. And thank you for also reminding us about what Henry wrote in the chat, where he is asking, or he's saying, well, those LLMs are pushed on us, but do we need them? Does it matter if there are some grammatical errors, especially given the cost of LLMs? I think that's a very interesting point. I just will briefly give my perspective on that, and then if anyone else wants to contribute. I think, yeah, maybe we wouldn't have needed them. I'm still, one thing that is often discussed with all these AI technologies, that AI will at some point save us from the climate crisis. I don't see that yet, and I'm also not sure if that's actually going to happen. In my opinion, probably not. And do we need it for other stuff? I think, as Ella also pointed out, of course, it opens new possibilities that, for instance, people from different cultures with completely different languages can work together more easily now. And I do think, given that it is there now, I feel sometimes also in my teaching and so on, students who are not using it are kind of falling behind if they want or do not want. And I think it feels like now that it is here, you don't really have a choice whether to use it or not. This is what I feel about this.
I think it's a cultural thing, because as long as we really prefer to have emails written the right way, and we prefer articles being, we do notice the proficiency and other things. I think that culturally we kind of tuned in to improve ourselves using those tools, and this is part of our culture and part of our norms. And so not using it actually gives us disadvantage. We are in a less advantage status unless we do know how to use them. But knowing how to use them, and maybe even changing the norms to be more to value authenticity over use of those tools, can be something that is valuable. And this is what we need to think about as a society, because this is in our hands. We can be the change. We can actually make things happen in the way that we value more people being people than being perfect at something. So
Yeah, Aish, you wanna?
I think Patrick raised his hand before me. Sorry.
I don't see Patrick's hand that well because he has a different color. Sorry.
You can go ahead, Aish. Go ahead.
Okay. Well, thanks. Henri, thanks for that comment. I think on some levels I agree, because I've also often felt, do we really need this? But on some levels, I also agree with Sandra and what Ella already pointed, that it's there now. And so we rather use it for some tasks where we can augment the performance instead of deciding absolutely not to use it. And so in this sense, I really feel it's like, really, maybe I'm repeating a little bit here, but what Ella said, I think it's about us on what task we want to employ it for. And GPT can, and as a tutor, it can sit with them, it can understand what concept they are lacking, and sort of push them in giving them a metacognitive feedback. So, which is not giving them the answer, but just gently pushing them towards the direction, addressing what concept it's missing, and trying to make that concept clearer. And in this way, it's a little bit something a student can have as a teaching model that is adapted to the student. So depending on how it's used and for what we use it, I could see benefits in that sense. And Patrick, thank you for giving me the stage first. Over to you.
You're very welcome. So I want to continue talking about being optimistic versus pessimistic about the future of AI. So first of all, I personally do think that the internet was a great invention, but that like this AI thing made it, well, now maybe a little bit more efficient to use. But the great invention behind, for me at least, is the internet. I mean, we had these inventions like language, which changed quite a bit. There's lots of technical innovations that people needed to adjust, which had positive and negative things. And maybe we might agree that large language models have lots of potential to have more benefits than pitfalls. But either way, the thing what I wanted to throw in the pit is that those large language models are pretty proprietary for the most part, and the people that are evolving them are putting billions and billions of dollars into building new data centers, and so they kind of own the models. And if we accept as a society that we want to incorporate those models into everything, it's kind of an issue that they are not owned by the society, really. That's my take on it, because they are intimately linked to how everybody on Earth, or most of the people, are thinking. And then maybe it should be more of a public good, because when I'm looking at search engines, for example, it's very similar. Many people use it, and they get worse and worse because corporate interests get pushier and pushier, and they want to get more and more money out of it. So ads get higher ranked and higher ranked, and search engines get less and less and less efficient. And I just see the same thing happen with large language models when they are just owned by corporate. And I think that's the thought I wanted to. That's a little bit pessimistic, where we might need to be cautious.
Thank you, Giacomo.
I wanted to something that was captured my attention with something that Aish said you was referring to when you say it's clear that the way the student interface, the power of GPT or the GPT technology is that it adapts to the student. This is clear, and you made this example that the teacher can be ineffective, and while GPT will never stop until a certain knowledge. But my doubt is ideological, okay, my approach. But to be at the university, for example, for a student, as a student also, my experience is not only about becoming professionally skilled in a certain aspect, but is really growing as human being, growing as individual. So and reality doesn't adapt to me. I mean, that's a normal experience. I mean, I don't. The reality is diverse, is complicated, is beautiful, but also challenges me. And a teacher that is ineffective is a normal. I mean, I as a supervisor, I do feel the drama. Okay, every time I face, I have I'm lucky to be able to interface with a student, that I will fail in some part, and that's a dramatic aspect that I cannot avoid. And I don't think avoiding it is something that is necessarily good. I mean, I think it's also fine to fight that fight. You see, I mean, so I don't. Maybe removing that part is becoming us very efficient machines, maybe but less human. I don't know.
So I think I have to jump in here just to clarify that I absolutely don't think teachers would at any point be ineffective. I think teachers and supervisors are absolutely needed in building learning. Where I could see a potential use case is in this extra hours to clarify things that were not done in the class, or to really follow up with some concept that was still missed out. And in this sense, it's sort of like a support to the teacher, but not ever, I cannot imagine it replacing the teacher, because I absolutely agree, Giacomo, the reality is way more complex than maybe that an LLM model could comprehend, at least as of now. And in that sense, I think we do need humans for literally everything there. So yeah, that's not the ideology I support as well. So.
Yeah, we forget it is being more or less human. We also received a comment from our YouTube audience where someone wrote, I think we may have to revise what is us. I've been wearing eyeglasses since age of 10. By now, they're part of me. We may have to accept that the phones and AI would become parts of us at the same way. Yeah, I think we're tackling here a point that we were already touching on before, with like extended mind, extended cognition. Are those technology a part of us? Which is yeah, a big philosophical question. There's also the movement of transhumanism you might have heard of, where it is discussed that yeah, we as humans become supplemented, and this example of a person wearing glasses, like also me, I would already count as a cyborg according to transhumanism, because it improves my performance because I actually see what is written here in the comments. Yeah, I think this is a big philosophical topic. Maybe someone has some ideas or thoughts on it.
Well,
maybe sorry, Patrick, go ahead.
Yeah, I'll just put in some thoughts there. Yeah, I mean, it's very similar to the unit of analysis concept that I mentioned earlier, at least from my point of view. My gut feeling is that it's tough to incorporate too many things into what our human body is, because maybe I'm a little bit conservative there, but it's somehow a little bit dangerous, especially when you incorporate things into yourself that are not in your own control. Losing control is not something that's taken easily. And if you incorporate AI models that might sometimes not be available, or that might not be owned by society, or that might also be changed by, I don't know, political parties in power, then they can change who you are, and that's kind of a problem, I think. So we might need some borders to protect ourselves as individuals. I'm not quite sure where those borders would need to be, but it's definitely not taken easily.
Thank you, Patrick. I think we discussed a lot. I think we had, yeah, although we have different disciplines here, quite things that are, yeah, on all of our minds, although coming from very different directions. Yeah, come on.
Yeah, sorry, Sandra. just feel free to not give me word anymore if you want. But I really first again I'm thanking you all again. I'm really enjoying it too much probably. So that's why I keep. But I wanted to ask change a bit of subject. Maybe a question is. I try to formulate it. I think it's more for Patrick, but maybe also for the others. It's about, and it came again, something that Aish was mentioning in her talk, that in astronomy there is a lot of abstraction, say, in what we do, in what we learn, right? And I was wondering, okay, indeed, there is the difference between abstraction and concrete knowledge. I was wondering whether these imply a difference with respect of learning strategies. What I mean is, like, for example, the ratio between internal and external strategies changes if the subject of the knowledge is abstract with respect to concrete or not. And the other end, if LLM model might have, or the user AI is more, so have more consequences, when the knowledge is abstract with respect to concrete. I mean, to learn. I mean, if I want to know how to do a cake, I ask and I get a recipe. If I want to learn astrophysics and the way a star works, I go and ask, is this the same? So does it have the same consequence in my internal learning? You call it sorry. Yeah, I hope it's not too confusing.
I'm just throwing my quick answer in here. So I mean, I think the quick answers I can't sufficiently answer the question. I think what for some cognitive functions is the case that having an external aid can even be better in terms of building abstract knowledge, because when you look at the memory example, you might skip those teeny tiny memory traces to tell you what 5 times 7 is, for example. But it might, using external strategies can give you more resources to see the bigger picture, even if you miss out on these tiny memory traces. And there is some evidence that in some cases this is actually true, but answering whether this is also the case when having a concept like learning astrophysics, which is a very big concept, I don't know.
Thanks.
Fabio?
I share Giacomo's feeling. So I have so many questions and thoughts. I don't think I will sleep tonight. But to bring back to some technical stuff, I would like to summarize what I learned today, because I have also some questions. I bring them and then see if it can be answered. So as a software developer, I understood that the reaction time of a language model is important. So what I would do is to give immediately an answer, even a fake one, or like nice question, or even asking a fake answer while in the background a process is running, if I understood correctly the point. So as a human being, we don't want to waste time. So reaction time plus all the other things, if I understood correctly. Then there are some statements, I think from Sun, I took note, says AI cannot find causal model for observations. Only humans can. And this is the main question is it related to intuition? So we humans can have this more than a machine, because a machine has all the information possible available. And what is intuition then? So an unconscious process going in the background. And another comment was LLM cannot understand images. And I think this is another question for maybe tomorrow. It's a language model. So maybe we are using the wrong tool to do some stuff. So we are communicating with a machine using a very human tool with limitations. So I don't know. I'm really asking if this is the right tools. on the positive and negative side, I was one of the guys early back in time who thought that internet would have brought us freedom, because everybody could access information, so and connect to each other and talk to each other. So it was just positive. After so many years, we have conspiracy theories, fake news, trolls, you name it. Language model, I think, is the same. So we are talking about something that has the knowledge. So everything we know as a human race, something we cannot have as humans. So potentially a language model has a lot of answers, but we cannot ask the right questions. And the last technical question, then I close, I think it's from, I don't know who was it. Yeah, about the models to teach. It was mentioned GPT, and I was asking if GPT is the best model, or there are other models more suitable, or was just used GPT for, I don't know, economical reasons. I close here. Thank you very much to all of you.
Thank you. I think San and Ali-Dib but Mohamad are not here anymore. I think because of the time differences, they're like far away from our time zone. But I think Patrick could definitely answer the first part.
Yeah, actually, I only wanted to comment on the causality question. So from what I understood, that there's a movement that you can improve AI models by letting them engage with the environment, because that's what they're currently missing. So if you only have a language database, you can't do experiments like cognitive scientists do. But if you have an agent that can interact with the environment, you can bring causality into the equation. And that's maybe when the potential that those AI models have will explode, maybe, I don't know. But I think that's where causality could be brought in, if they can really interact with what's going on in the environment.
Maybe to add with regard to the speed part that you had at the beginning, as far as I would say, I think what matters is how fast the LML gives you the answer that you want. I'm not sure if it would help if it like gives you a fast random answer to just take more time to come to the correct answer. So I'm not sure, Patrick, maybe you know something of this, but my feeling is that wouldn't help. It helps if it gives you fast the correct answer, but just like stalling and keeping you amused with something else, I'm not sure if that would actually help.
Yeah, so yeah, I think like, sorry.
Okay, so you are talking about the real answer, the final answer. So not the first reaction.
Yeah, the real answer, I think. Yeah.
Okay.
Yes. So I was talking also in my talk about the real answer. If giving some intermediate random answers will improve things, I don't know, but it definitely also, like, if somebody likes to be accurate because he's maybe working in a critical sector, and lives are being lost if there's the wrong answer, then probably he won't appreciate quick answers that are wrong. I mean, that's for sure. And yeah.
Nice.
Yeah, just to add to the speed context, I've from my personal experience, I've seen GPT take time when it needs time. It will give a short reply saying, okay, I'm analyzing this and I get back, and it takes time. I cannot guarantee if it's correct, the answer after that or not, but I've seen it taking time.
Well, thank you. I think we're coming to an end, and we're approaching our end of the day time that is put here on my schedule. I think we had a wonderful discussion. Thank you all. Thanks very much again to our speakers for taking the time and contributing to this. I hope that, yeah, we as psychologists could add something to this astronomy conference. So thanks a lot, everyone, for taking the time. I think if there are more things to exchange, you will find each other's email contacts online. And yeah, who knows, maybe there will be some collaborations for astronomy, psychology projects. So thank you a lot, and yeah, have a good evening. And yeah, we have 2 more workshop or conference days ahead, I think, Giacomo. I'm not sure if you want to say something about that.
Well, yes, I would just to join you in thanking everyone. Thank you, the speakers. Thank you, Sandra. You did a spectacular job in chairing the session and moderating. Really, really thank you. Thank you also for the atmosphere. Very polite, very respectful. This is really important, and I'm really, really thankful to everyone for that, but also for the professionality. I learned a lot. Really, 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 and really, really beautiful. Thank you all. Thank you very much. For collaborative, yeah, I will think of some, because for sure we will draft a paper out of this event. So we might interface with you to ask you feedback at some point. With Henri, we will see. Anyway, there are 2 more days. Tomorrow we will discuss the impact of use of GPT technologies on hiring and hiring processes and evaluation processes. You can imagine sending a proposal, sending a research plan, the impact of AI MC, right, in writing and formulating concept, how this will affect our way in which we evaluate then these proposals or research plan or whatever. That's the thing of tomorrow. And then the last day is about ethics and impact on let's say, on publications. So again, so we will have a talk from Nature Astronomy editor to tell us, and we will try to understand how this is impacting also the literature and the way we publish research and science, and whether there are ethical things to take into account. So this is the last 2 days. As I said, this event has been streamed on YouTube, and it will stay on the playlist, so people can watch it in the future. And you can also see the other days are already there. So please feel free to watch. There is a lot of stuff in our ESO Cosmic Duologue webpage, so you can see other talks. Anyway, with this, yes, I will thank you so much to everyone. And thank you, Sandra. Thank you, all the speakers. Thank you, Ella. Thank you, Patrick. Thank you, Aish, for being with us. Thank you to the attendees, and see you tomorrow. Bye.
Thank you. Have a good evening.
Bye-bye.
Bye. Thank you.
Bye.
Bye.